The Big Bang did not bang. There was no explosive sound echoing through the cosmic void, no fiery blast illuminating primordial darkness, no moment when nothing suddenly became something. The beginning of our universe, that singular moment scientists have spent centuries trying to understand, was never a beginning at all. What if everything you've been told about cosmic origins is fundamentally incomplete? What if the universe as you know it, all the stars, galaxies, planets, and the very space between them is merely the interior of something far more extraordinary? A black hole in another, larger universe? Take a moment. Let that possibility sink in. You exist inside a black hole, the boundary you can never cross, the cosmic horizon beyond which astronomers cannot see. It's not just a limitation of our instruments or the speed of light. It's the event horizon of our parent black hole, a membrane separating our reality from an unfathomable exterior universe. If you could rewind time, what would you see? A moment of creation, or something else entirely? As we journey together through this cosmic labyrinth, prepare to question everything you thought you knew about reality itself. The theory sounds preposterous at first. Black holes have been portrayed as cosmic monsters devouring everything in their path, crushing matter into oblivion. How could one possibly contain an entire universe? How could our vast, expanding cosmos be contained within anything? Yet the mathematics tells a different story, one that has been whispering to physicists for decades. The equations that describe black holes bear an uncanny resemblance to those describing expanding universes. This is not coincidence. This is a clue etched into the fabric of reality itself. Picture yourself standing on the shore of an endless ocean at night. The darkness extends beyond what your eyes can perceive, waves rolling into infinity. This ocean is our universe, but unlike Earth's oceans, it doesn't just extend outward. It expands. Every second, this cosmic sea grows larger, distances stretching, between galaxies like islands drifting apart. But what lies beyond this expanding ocean? What if our entire universe is merely a drop in a much larger sea? Consider what happens when a massive star collapses. Its core implodes under its own gravity, compressing to an infinitesimal point, a singularity. Around this singularity forms an event horizon, a boundary from which nothing, not even light, can escape. From the outside, time appears to freeze at this boundary. But what about from the inside? What happens to space and time within a black hole's event horizon? Einstein's equations of general relativity, the mathematics describing how gravity warps space-time, don't just allow for this possibility. They almost demand it. When a black hole forms, space-time doesn't simply vanish inside the event horizon, it transforms. It creates a new region where space and time behave differently, potentially giving birth to entirely new physics, new dimensions, new possibilities. You might wonder why this idea isn't taught alongside standard cosmological models. The truth is, this theory challenges our deepest assumptions about reality. It forces us to confront the possibility that what we call the universe is merely one layer of an infinite cosmic onion, each layer a universe unto itself, each universe a black hole in another universe, stretching endlessly in both directions. Close your eyes for a moment. Imagine yourself floating in the void before the Big Bang. There is no space, no time, no matter, at least not as we understand them. Now picture a black hole forming in a parent universe we cannot see. Matter collapses, creating a singularity. But instead of a point of infinite density, This singularity rebounds, exploding outward in a new dimensional framework, what we call the Big Bang. This isn't merely philosophical speculation. The mathematics of Einstein's field equations supports this interpretation. When physicists solve these equations for the interior of certain black holes, they find something remarkable: conditions matching those of an expanding universe like our own. Think about the cosmic microwave background radiation, that faint glow permeating all of space, the oldest light in the universe. We interpret it as the afterglow of the Big Bang. But could it instead be the imprint of our parent universe's light, distorted and transformed as it crossed into our reality through the event horizon? The universe whispers its secrets in the language of mathematics and physics. We've been listening, but perhaps we've been interpreting the message incorrectly. What we call the beginning of time might actually be a transition, a passage from one cosmic realm to another. Consider the puzzling nature of dark energy, that mysterious force accelerating the universe's expansion. Cosmologists struggle to explain why this force exists and how it works. But if our universe exists within a black hole, this acceleration takes on new meaning? It could be the echo of conditions in the parent universe, influencing our reality through the barrier of the event horizon. You've been taught that black holes are endings, places where matter meets its doom. But what if they're actually beginnings? What if every black hole in our universe is the seed of a new cosmos, budding off from our reality to form its own space and time? Our universe would then be both child and parent, born from a black hole, and giving birth to countless others. This cosmic perspective forces us to reconsider the very meaning of everything. When we speak of the universe, we typically mean all that exists physically. But if our universe is merely one black hole among many in a parent universe, and if each black hole in our universe contains its own child universe, then reality is vastly more complex than we've ever imagined. Imagine a cosmic tree of universes, branching, growing, extending in dimensions we cannot perceive. Our universe isn't the trunk or the root. It's just one branch among countless others. And just as a branch can never perceive the entire tree, we may be fundamentally limited in our ability to comprehend the full scope of reality. The boundary of our observable universe, the cosmic horizon beyond which we cannot see, takes on new significance in this framework. It's not just the limit of our observational capabilities, it could be the very boundary of our reality, the event horizon of our parent black hole. When you gaze at the night sky, you're looking at stars and galaxies within our cosmic bubble. But no matter how powerful our telescopes become, we can never see beyond a certain distance. This isn't just because light hasn't had time to reach us. It's potentially because we're looking at the walls of our cosmic prison, or perhaps our cosmic womb. This theory resolves one of the most perplexing questions in cosmology. What happened before the Big Bang? The question itself becomes meaningless if the Big Bang wasn't the beginning of everything, but merely a transition. Time as we experience it may have begun with the Big Bang, but causality extends beyond, into the parent universe from which our reality emerged. You might wonder about the fate of our universe. If it is indeed a black hole in another universe, what does that mean for our cosmic future? Traditional models suggest several possibilities. A big freeze, where expansion continues forever. A big crunch, where gravity eventually pulls everything back together. Or a big rip, where dark energy tears apart the very fabric of reality. But the black hole universe theory suggests another possibility. The boundary conditions of our reality, the physics operating at the edge of our cosmic horizon, might be influenced by conditions in the parent universe. Our fate may be intertwined with cosmic processes beyond our comprehension or observation. The concept challenges not just our understanding of cosmology, but our place within reality itself. Humans have progressively discovered that we're not at the center of the solar system, that our sun is merely one of billions of stars in the Milky Way, and that our galaxy is one among trillions in the observable universe. Now, we must contemplate that our entire universe might be just one bubble in an infinite cosmic foam. This doesn't diminish our existence. If anything, it makes it more remarkable. The atoms in your body, the electrons and quarks comprising your physical form, may be connected to a cosmic lineage extending through multiple layers of reality. You aren't just stardust. You're the descendant of processes spanning multiple universes. Consider the profound silence of space. In the vacuum between stars, sound cannot travel. Yet if our universe exists within a black hole, this silence takes on new meaning. Perhaps it's not just the absence of air that creates this silence, but the fundamental separation between our reality and the parent universe. We exist in cosmic isolation, unable to hear the sounds of the greater cosmos. The boundary of a black hole, the event horizon, is not a physical surface, but a region where space-time bends so extremely that light can no longer escape. From the outside, time appears to freeze at this boundary. But on the inside, time marches forward. If our universe is inside a black hole, then the moment of its formation, what we call the Big Bang, might still be occurring from the perspective of the parent universe. What we experience as 13.8 billion years of cosmic evolution might be just an instant in the frame of reference outside our reality. This temporal relativity extends to black holes within our own universe. When we observe a black hole forming, we never actually see the event horizon form completely. Time appears to slow down asymptotically. But if a universe forms inside, for its inhabitants, time proceeds normally. Their entire cosmic history could unfold in what we perceive as a moment. The mathematics supporting this theory comes from extensions of Einstein's field equations, the same equations that predicted black holes, gravitational waves, and the expansion of the universe long before we had observational evidence for any of these phenomena. These equations describe how space-time curves in response to matter and energy. When solved for certain conditions, they reveal the possibility of new expanding spacetimes forming inside black holes. What would it mean to test this theory? How could we possibly gather evidence about realms beyond our cosmic horizon? The answer lies in the detailed predictions this model makes about the properties of our own universe, its rate of expansion, the distribution of matter and energy, the subtle patterns in the cosmic microwave background radiation. If these predictions match observations more precisely than competing theories, it would lend credibility to this extraordinary perspective. But even if we gather compelling evidence, we must acknowledge the inherent limits of our cosmic perspective. We are like two-dimensional beings trying to comprehend a three-dimensional world, or ants trying to understand quantum mechanics. Some aspects of reality may lie fundamentally beyond our ability to observe or conceptualize. This doesn't mean we should stop trying. The history of science is filled with concepts once thought to be beyond human comprehension that are now part of our basic understanding of reality. The curvature of space-time, quantum entanglement, the wave-particle duality of matter, these were once as mind-bending as the concept of universe-containing black holes. When you look at a black hole, or rather, at the accretion disk of matter swirling around it, you're seeing matter in its final observable state, before it crosses a boundary beyond which we cannot follow. But what if that boundary isn't an ending but a beginning? What if every black hole is a cosmic seed, containing within it the potential for an entire new universe with its own stars, galaxies, planets, and possibly even life. This perspective transforms our understanding of cosmic evolution. The formation of black holes, which occurs regularly throughout our universe as massive stars collapse, becomes not just an interesting astrophysical process, but a form of cosmic reproduction. Our universe isn't just expanding, it's potentially giving birth to countless child universes. The concept of cosmic natural selection, proposed by physicist Lee Smolin, extends this idea further. If universes can give birth to other universes through black holes, then a form of cosmic evolution might occur. Universes that produce more black holes would give birth to more child universes, which would inherit similar physical properties. Over time, a concept that takes on new meaning when discussing multiple universes, reality itself might evolve toward conditions that maximize the production of black holes and, consequently, child universes. This connects to another puzzling aspect of our universe, its apparent fine-tuning for complexity and life. The fundamental constants of nature, the strength of the four forces, the mass of elementary particles, the cosmological constant, seem precisely calibrated to allow for the formation of stars, galaxies, and the complex chemistry necessary for life. Even slight variations in these constants would create universes where complexity could never emerge. While some interpret this fine-tuning as evidence for a cosmic designer, the black hole universe theory offers an alternative explanation. Trito, universes evolve through a process analogous to natural selection. With black hole production as the selection criterion, then we should expect to find ourselves in a universe capable of producing plenty of black holes. Interestingly, the same conditions that allow for plentiful black hole formation, stars, galaxies, complex elements, also happen to enable life. You might wonder about the origin of this cosmic evolutionary tree. If our universe emerged from a black hole in a parent universe, and that universe potentially emerged from another, does this chain extend infinitely into the past? Or was there some primordial universe that started it all? These questions might be fundamentally unanswerable, much like asking what exists north of the North Pole. They might require us to think beyond our linear conception of causality. The geometry of spacetime inside a black hole differs profoundly from the relatively flat spacetime we experience in our daily lives. As matter collapses toward the singularity, spacetime curves more and more extremely. In some mathematical models, this curvature can lead to a bounce rather than a true singularity, a Dewey transition where collapsing space begins to expand again, but in a new dimensional framework. This bounce could be what we experience as the Big Bang, not a beginning from nothing, but a transition from contraction to expansion. The mysterious dark energy accelerating our universe's expansion might be related to this bounce, a cosmic echo of the collapse that preceded our universal expansion. When we observe the cosmic microwave background radiation, the oldest light in the universe, released about 380,000 years after the Big Bang, when the universe cooled enough for electrons to combine with protons, we're looking at the afterglow of this transition. The slight temperature variations in this radiation, which we've mapped with increasing precision, might contain hidden information about the parent universe or the black hole that gave birth to our cosmos. The theory also offers a new perspective on the arrow of time. The puzzling fact that time seems to flow in only one direction, even though most physical laws are time-symmetric. The thermodynamic arrow of time, linked to increasing entropy, might be connected to our universe's expansion, which itself could be an echo of the collapse in the parent universe. Time flows in the direction of increasing entropy in our universe, because we're on the expansion side of the bounce. You might wonder about the physics operating at these cosmic boundaries. What happens exactly at the event horizon of our parent black hole? What physical laws govern the transition from one universe to another? Current physics breaks down at these extreme conditions with general relativity and quantum mechanics, our two most successful physical theories, giving contradictory predictions. A complete theory of quantum gravity, the holy grail of theoretical physics, would be necessary to fully describe these transitions. While several approaches exist, from string theory to loop quantum gravity, none has yet provided a complete and testable description. The black hole universe theory might actually guide the development of such theories by suggesting specific conditions and boundaries they would need to describe. Consider the philosophical implications of this cosmic perspective. If our universe is one among many in a vast multiverse connected through black holes, what does this mean for concepts like determinism, purpose, or even existence itself? Are the physical laws we observe fundamental, or are they emergent properties, specific to our universe? Could there be other universes with entirely different physics, different dimensions, different conceptions of time? These questions verge on the metaphysical, but they arise naturally from the mathematics of cosmology. They force us to recognize the limitations of our perspective while simultaneously expanding our conceptual horizons. For most of human history, we've placed ourselves at the center of reality. We once believed Earth was the center of the universe, with celestial objects revolving around us. We've progressively discovered our cosmic insignificance. Our planet orbits an average star in the outer regions of an average galaxy, which itself is one among billions of visible galaxies. Now, we must contemplate that our entire cosmos might be just one bubble in an infinite cosmic foam. Yet there's something profoundly meaningful about this perspective, too. If our universe was born from a black hole and will give birth to countless others through its own black holes, then we're part of a cosmic continuity that transcends our limited conception of space and time. The iron in your blood, forged in the hearts of dying stars, might have originated in the parent universe before crossing into our reality. Imagine standing on the shore of the cosmic ocean again. The waves you see are just the visible surface of something far deeper. Beneath these waves lies an abyss of reality we cannot directly observe. The water molecules themselves might have cycled through multiple oceans, multiple states of being. Similarly, the fundamental particles comprising our reality might have histories extending beyond the Big Bang, beyond our universe itself. The black hole universe theory transforms our conception of cosmic origins. Rather than a singular creation event, a moment when everything came from nothing, it suggests a continuous process of cosmic reproduction. Universes give birth to other universes in an endless cycle of death and rebirth. The Big Bang wasn't the beginning of everything. It was merely the beginning of our cosmic chapter. This perspective resonates with certain philosophical and religious traditions that conceptualize reality as cyclical rather than linear. Ancient concepts like the Ouroboros, the serpent eating its own tail, or the Hindu notion of cosmic cycles find unexpected echoes in this cutting-edge physics. Perhaps our ancestors intuited something profound about reality that we're only now rediscovering through mathematics and observation. When you observe a black hole through a telescope, seeing not the hole itself, which emits no light, but the glowing accretion disk around it, you're witnessing both a cosmic end and potentially a cosmic beginning. The matter swirling into oblivion from our perspective might be the raw material for an entirely new universe from another perspective. The theory also offers new ways to think about the apparent fine-tuning of our universe for complexity and life. Rather than requiring a cosmic designer or extremely improbable chance, it suggests a form of cosmic evolution. Universes that produce more black holes give birth to more child universes with similar properties. If the conditions that enable black hole formation also enable complexity and life, then most universes in the cosmic evolutionary tree would have these features. This doesn't fully resolve questions about our cosmic purpose or significance, but it reframes them. We're not accidents in a singular random universe, nor are we the special creation of a cosmic designer. We're participants in an ongoing cosmic process that transcends our limited conceptions of space and time. The black hole. Universe theory remains speculative, sitting at the frontier of theoretical physics. It's not yet the scientific consensus, and aspects of it may be modified or disproven as our understanding advances. But it represents the kind of bold thinking necessary to push the boundaries of human knowledge. What would it mean for humanity? If this theory proved correct, how would it change our place in the cosmic story? For one, it would confirm that reality is vastly more extensive and complex than we've imagined. Our universe, already mind-bogglingly large with its hundreds of billions of galaxies, each containing hundreds of billions of stars, would be just one bubble in an infinite cosmic foam. This might seem to diminish our significance further, but it also connects us to a larger reality. The matter and energy comprising our universe, and by extension ourselves, would be part of a cosmic lineage extending through multiple layers of reality. We would be both the children of one universe and, potentially, the ancestors of countless others. The theory also suggests a profound form of cosmic interconnectedness. Every black hole in our universe, formed when massive stars collapse or when galaxies merge, potentially creates a new universe. These child universes would inherit properties similar to our own, creating a form of cosmic heredity. The physics we observe wouldn't be arbitrary, but the result of a cosmic evolutionary process spanning multiple universes. Contemplate the night sky again. Those distant stars and galaxies exist within our cosmic bubble, but scattered throughout. That visible universe are black holes, regions where space-time curves so extremely that light itself cannot escape. These aren't just exotic astrophysical objects. They might be portals to other realities, cosmic wombs nurturing new universes. This perspective transforms how we understand our cosmic future too. The fate of our universe, whether it will expand forever, collapse back on itself, or reach some other end, takes on new meaning if we're part of a larger cosmic process. Our universe's death might contribute to the birth of others in ways we cannot fully comprehend. Consider the cosmic horizon, the boundary beyond which we cannot see, regardless of how powerful our instruments become. This horizon exists because the universe has a finite age, and light from more distant regions hasn't had time to reach us. But if our universe exists within a black hole, this horizon takes on new significance. It might be the very boundary of our reality, the event horizon of our parent black hole. The mathematics describing this boundary bears striking similarities to the mathematics describing black hole event horizons in our universe. This isn't mere coincidence, but a clue about the fundamental structure of reality. The equations of general relativity, when pushed to their limits, suggest these nested realities. You might wonder about the physics operating at these boundaries. What happens precisely at the event horizon of a black hole, or at the cosmic horizon of our universe? Our current physical theories break down under these extreme conditions. General relativity, which describes gravity as the curvature of space-time, and quantum mechanics, which describes the behavior of matter and energy at the smallest scales, give contradictory predictions. A complete theory of quantum gravity would be necessary to fully describe these transitions. While several approaches exist, string theory, loop quantum gravity, causal set theory, and others, none has yet provided a complete and testable description. The black hole universe theory might actually guide the development of such theories by suggesting specific conditions and boundaries they would need to describe. The concept of information conservation becomes particularly relevant here. A fundamental principle in physics states that information cannot be destroyed. It can be scrambled, encoded in different forms, but never completely erased. This creates a paradox for black holes, which appear to destroy information when matter falls into them. But if black holes give birth to new universes, perhaps this information isn't destroyed, but transferred into the child universe, preserved in a new form. This connects to questions about quantum entanglement, the mysterious phenomenon where particles become linked across space and time, with the state of one instantly influencing the other, regardless of distance. Some theoretical physicists propose that space-time itself might emerge from quantum entanglement. If so, the entanglement structure of our universe might contain encoded information about its parent universe. The theory also offers new perspectives on cosmic inflation, the period of extremely rapid expansion thought to have occurred in the first fraction of a second after the Big Bang. Inflation explains several observed features of our universe, including its remarkable uniformity on large scales and the specific pattern of density fluctuations that led to galaxy formation. But what caused inflation to begin and end remains mysterious. If our universe formed inside a black hole, inflation might be connected to the dynamics of the collapse in the parent universe. The extreme curvature of spacetime during this collapse could naturally lead to a period of rapid expansion when viewed from inside the resulting child universe. You exist at a unique moment in cosmic history, a time when humanity has developed the mathematical and observational tools to contemplate these profound questions. For most of human existence, we lacked the conceptual framework even to ask whether our universe might be a black hole in another universe. Now, we can not only ask, but develop rigorous mathematical models to explore the possibility. This represents a culmination of centuries of scientific progress, from Einstein's revolutionary theories of relativity to the development of quantum mechanics, from the discovery of cosmic expansion to the detailed mapping of the cosmic microwave background radiation. Each advance has revealed our universe to be stranger and more magnificent than we previously imagined. The black hole universe theory continues this tradition of expanding our cosmic perspective. It doesn't diminish the achievements of modern cosmology, but builds upon them, offering potential solutions to persistent puzzles while raising new questions that might guide the next century of discovery. When you consider the significance of this theory, remember that all major scientific revolutions initially seemed outlandish. Copernicus's proposal that Earth orbits the Sun rather than vice versa contradicted both common sense and the dominant philosophy of his time. Einstein's suggestion that time itself is relative, that gravity results from the curvature of space-time, seemed equally absurd to many of his contemporaries. Yet these revolutionary ideas eventually became the foundation of our modern scientific worldview. The black hole universe theory might represent a similar paradigm shift, a fundamental reconceptualization of cosmic reality. It transforms our understanding of beginnings and endings, of time and causality, of our place within an incomprehensibly vast cosmos. As we continue this cosmic journey together, remember that we're stepping into territory at the very frontier of human knowledge. We're contemplating questions that push the boundaries of our comprehension, that force us to recognize both the power and limitations of the human mind. What lies beyond our cosmic horizon? What exists outside our universe? These questions might seem unanswerable, and perhaps they are, at least directly. But through mathematics, through observation, through the careful development and testing of theories, we can glimpse aspects of a reality far more extensive and complex than our ancestors ever imagined. The Big Bang did not bang. It wasn't the beginning of everything, merely the beginning of our cosmic chapter. And as we turn the pages of this cosmic story, we discover that reality itself is grander, more intricate, and more profoundly interconnected than we ever dared to dream. The universe began 13.8 billion years ago. This is what we've been taught: a clean, precise number backed by measurements of cosmic microwave background radiation, the rate of expansion, and the distribution of elements throughout space. It's a cornerstone of modern cosmology, a scientific fact as solid as the ground beneath your feet. But what if this number, this seemingly concrete measurement, is merely the age of our cosmic bubble, not the true age of existence itself? Before we venture further into the black hole universe theory, we need to understand the stage upon which this cosmic drama unfolds. We need to explore what mainstream science tells us about our universe, and where the cracks in this narrative begin to appear. The standard model of cosmology tells us that approximately 13.8 billion years ago, all matter, energy, space, and time erupted from a singularity, a point of infinite density and zero volume. This initial state wasn't located anywhere in space because space itself didn't exist yet. It wasn't preceded by anything because time hadn't begun. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. In the first fractions of a second after the Big Bang, temperatures reached levels we can barely comprehend, trillions of degrees, hot enough to prevent even subatomic particles from forming. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were unified in a state of perfect symmetry. As this cosmic inferno expanded and cooled, symmetry broke, forces separated, elementary particles condensed from the pure energy of the void. Protons and neutrons formed, then atomic nuclei, then finally atoms themselves. The universe transformed from an opaque plasma into a transparent expanse, releasing the light we now detect as cosmic microwave background radiation. The first light free to travel through space, the oldest light our instruments can detect. This narrative, built on decades of observation and mathematical modeling, presents a universe with a definite beginning, a cosmic birth certificate with a precise date. But now, listen closely to the whispers of doubt in this cosmic story. If the universe began from a singularity, a point of infinite density, then we're immediately confronted with a problem. Our physics breaks down at infinities. The mathematics becomes nonsensical, producing results that cannot be interpreted physically. Singularities aren't features of the universe. They're warnings from our equations, telling us we've ventured beyond the limits of our understanding. Imagine sailing across the ocean using a perfectly detailed map. But at one specific coordinate, the map simply reads, "Here be dragons." This isn't a description of actual dragons. It's an admission that the mapmaker doesn't know what exists at that location. Cosmological singularities are physics' version of "Here be dragons," not descriptions of reality, but acknowledgments of our ignorance. The Big Bang Theory doesn't actually describe the moment of creation itself, but rather the rapid expansion that followed. It's like beginning a book on Chapter 2, with Chapter 1, the actual moment of creation, torn out and missing. We've constructed an elegant narrative of what happened after the beginning, while the beginning itself remains shrouded in mystery. What created the singularity? What caused it to expand? What existed before it? The Standard Model offers no answers to these questions because they exist beyond its conceptual framework. Time itself began with the Big Bang, we're told, so asking what came before is meaningless. like asking what's north of the North Pole. But this explanation, while mathematically consistent, feels profoundly unsatisfying. It doesn't eliminate the questions. It merely places them outside the boundaries of scientific inquiry. The universe, with its intricate patterns, complex structures, and mathematical harmony, seems too orderly to have emerged from absolute nothingness. There should be a story before Chapter 2. The black hole universe theory offers this missing, cured chapter. It suggests that the singularity from which our universe emerged wasn't the beginning of everything, but a transition, a passage from a parent universe through the gateway of a black hole. To understand this possibility, we need to explore the nature of black holes themselves, not as cosmic dead ends, but as potential cosmic wombs. When a massive star exhausts its nuclear fuel, gravity takes control. The outer layers may explode in a supernova, but the core collapses inward with unstoppable force. If this core has sufficient mass, typically at least 3 times that of our Sun, no known force can prevent its complete collapse into a singularity. Around this singularity forms an event horizon, a boundary defined by the point at which the escape velocity exceeds the speed of light. From the outside, a black hole appears as a perfect sphere of darkness, a region of space that emits nothing, reflects nothing, reveals nothing. But the mathematics describing these objects, derived from Einstein's general relativity, suggests something far more complex occurs within. When matter falls into a black hole, it doesn't simply cease to exist. Conservation of energy, one of physics' most fundamental principles, forbids such disappearance. Instead, this matter and energy must go somewhere, must transform into something. But the event horizon prevents us from observing this transformation directly. We can never see what happens to an object once it crosses this cosmic point of no return. Or can we? Consider a thought experiment. Imagine you're an astronaut falling into a supermassive black hole. From the perspective of a distant observer, say, your colleague watching through a telescope from a safe distance, your descent would appear increasingly strange. As you approach the event horizon, the extreme gravitational field creates a profound time dilation effect. To your distant observer, your clock would appear to tick ever more slowly. Your movements would seem to decelerate. Your radio transmissions would stretch to lower and lower frequencies. You would appear to freeze at the event horizon itself, never quite crossing it from the external perspective, but from your perspective, falling freely through space. Nothing special happens at the event horizon. You cross it without feeling anything unusual. Time flows normally by your watch. The universe behind you continues to look ordinary, albeit increasingly concentrated into a shrinking circle of visibility above you as the warped space-time affects the path of light. This dramatic difference in perspectives between observer and observed reveals something profound about black holes. They create a fundamental disconnect between realities. What appears from the outside as an endpoint, a cosmic full stop, might experience from the inside as a transition, a passage into something new. The mathematics of general relativity supports this disconnection. When solved for the interior of a black hole, Einstein's field equations yield solutions that resemble an expanding universe. Let that sink in for a moment. The mathematical description of space-time inside certain types of black holes bears a striking resemblance to the mathematics describing an expanding universe like our own. This isn't merely an interesting coincidence. It's a signpost pointing toward a deeper truth about cosmic structure. In the language of differential geometry, the mathematics used to describe curved space-time, the interior of a black hole can be mapped to a new, coordinate system that describes an expanding spacetime. The singularity that appears to be a point from the outside perspective transforms, in this new coordinate system, into a moment in time, the beginning of expansion. This is not merely abstract mathematics. It's a potential description of physical reality. The same equations that successfully predict the bending of light around the sun, the precise orbit of Mercury, the existence of gravitational waves, and countless other confirmed phenomena also suggest this surprising connection between black holes and expanding universes. Consider our cosmic horizon, the boundary beyond which we cannot see, regardless of how powerful our instruments become. This horizon exists because the universe has a finite age, and light from more distant regions hasn't had time to reach us. But its properties bear an uncanny resemblance to the event horizon of a black hole. Both are boundaries beyond which information cannot pass, both separate regions of space-time that cannot communicate with each other. If our universe exists within a black hole, this cosmic horizon takes on new significance. It becomes not just a limitation of our observational capabilities, but the very boundary of our reality. The event horizon of our parent black hole viewed from the inside. But if our universe is inside a black hole, how can it be expanding? Isn't a black hole a compact object with a definite size? This question reveals a common misconception about black holes. From the outside, a black hole appears to have a definite size, the radius of its event horizon. But this size measurement assumes an external frame of reference, a coordinate system in which the black hole exists as an object within a larger space-time. From the inside, if such a perspective is physically meaningful, the geometry could be entirely different. Space-time could expand indefinitely, while still remaining contained within what appears, from the outside, as a finite object. This seeming paradox results from the extreme curvature of space-time near and within the black hole. Imagine an ant living on the surface of a balloon. As the balloon inflates, the ant observes its two-dimensional universe expanding in all directions. From the ant's perspective, confined to the balloon's surface, this expansion could continue indefinitely. Yet from our three-dimensional perspective, we see the balloon as a finite object with a definite size. Both perspectives are valid within their respective reference frames. Similarly, our expanding universe could be contained within a black hole while experiencing no boundaries from within. The mathematics of general relativity allows for precisely this kind of geometric arrangement. This theory offers elegant solutions to persistent cosmological puzzles. Consider the horizon problem. Why does the cosmic microwave background radiation appear so uniform in all directions, even though regions on opposite sides of the sky couldn't have communicated with each other given the age of the universe? Cosmic inflation, a period of exponential expansion in the universe's first fraction of a second, is the standard explanation. But if our universe formed from the collapse of matter in a parent universe, this uniformity might have a different origin. The matter that formed our universe would have had time to reach thermal equilibrium before collapsing into the black hole, naturally explaining the observed uniformity. Or consider the flatness problem. Why is the universe so precisely balanced between expanding forever and eventually recollapsing? The density of matter and energy appears fine-tuned to an extraordinary degree, poised on a cosmic knife edge between these fates. If our universe is a black hole, this flatness might result from the conditions of its formation. The collapse of matter in the parent universe might naturally create a child universe with specific geometric properties, including this remarkable flatness. The theory even offers a new perspective on dark energy, that mysterious force accelerating our universe's expansion. Rather than requiring an unexplained energy permeating space, this acceleration might be an echo of conditions in the parent universe, influencing our reality through the boundary of the event horizon. These connections aren't mere speculation. They emerge from the mathematics of general relativity when pushed to its logical conclusions. While aspects of the theory remain speculative, they're grounded in our most successful description of gravity and space-time. Now, let's delve deeper into the mechanics of how a universe might form inside a black hole. When matter collapses to form a black hole, it doesn't simply vanish at the singularity. In classical general relativity, this matter would indeed be crushed to a point of infinite density. But quantum physics, which governs the behavior of matter at the smallest scales, forbids true infinities. When we attempt to combine quantum mechanics with general relativity, an incomplete project that represents one of the greatest challenges. In theoretical physics, we find hints that singularities might be replaced by bounces. Instead of matter collapsing to a mathematical point, quantum effects might cause it to rebound, creating a new expanding region of space-time. This process would be invisible from the outside. To an external observer, the black hole would appear normal, gradually evaporating over unimaginably long timescales due to Hawking radiation. But inside, a new cosmos would bloom, experiencing its own expansion, its own evolution, its own possibility for complexity and life. The matter and energy falling into the black hole would provide the raw materials for this new universe. Conservation laws would be preserved, not violated. Information wouldn't be destroyed, but transformed, encoded in the structure of the child universe. This perspective transforms our understanding of black holes, from cosmic graves to cosmic cradles. Every black hole in our universe, whether formed from collapsed stars, merging neutron stars, or the supermassive behemoths lurking at the centers of galaxies, becomes a potential universe in its own right, a new branch on the cosmic tree. But this raises a profound question. If our universe, formed inside a black hole, and can itself give birth to new universes through its own black holes, where did it all begin? Is there an original universe that started the process, or does the chain extend infinitely in both directions? This question might be fundamentally unanswerable, much like asking what's north of the North Pole. It might require us to think beyond our linear conception of causality, beyond our intuitive understanding of beginnings and endings. Perhaps reality is not a linear sequence, but a vast network, a cosmic web of interconnected universes branching and rebranching through higher dimensions we cannot directly perceive. Perhaps the very concept of an original universe is meaningless in this context, like asking for the first point on a circle. This cosmic perspective forces us to reconsider fundamental aspects of reality that we typically take for granted. Space and time themselves become relative concepts, dependent on reference frames that might differ dramatically between universes. The dimensions we experience, 3 of space and 1 of time, might be specific to our universe rather than fundamental to all reality. Other universes might have different dimensional structures, different physical laws, different possibilities for complexity. Consider the cosmological constant, the value associated with dark energy that appears fine-tuned to allow for the formation of galaxies, stars, and ultimately life. In the Standard Model, this fine-tuning seems to require either extraordinary luck or a multiverse with varying constants, allowing for anthropic selection. But if universes evolve through a process similar to natural selection, with black hole production as the selection criterion, this fine-tuning takes on new meaning. Universes that produce abundant black holes would give birth to more child universes with similar properties. Over cosmic generations, the population of universes might naturally evolve toward conditions that maximize black hole production. Interestingly, the same conditions that favor black hole formation Stars, galaxies, complex matter also favor the emergence of life. Our universe isn't fine-tuned for life specifically, but for black hole production, with life as a possible side effect. This evolutionary perspective connects to the concept of cosmic natural selection, proposed by physicist Lee Smolin. It suggests that the apparent design we observe in cosmic parameters isn't the work of a designer, but the result of a selection process operating across multiple universes and tremendous timescales. But if our universe exists within a black hole, why don't we see evidence of the parent universe? Why can't we detect influences or signals from outside our cosmic bubble? The answer lies in the nature of the event horizon itself. This boundary fundamentally separates regions of space-time, preventing information from crossing from outside to inside. We cannot see beyond our cosmic horizon for the same reason that light cannot escape a black hole. The geometry of space-time forbids it. However, the parent universe might leave subtle imprints on our cosmic parameters. The conditions of the black hole's formation, its mass, angular momentum, charge, might influence the fundamental constants of the child universe. These connections would be indirect, encoded in the basic structure of our reality, rather than observable as distinct signals. The theory also offers a new perspective on quantum entanglement, the mysterious phenomenon where particles become linked such that the state of one instantly influences the other, regardless of distance. Some theoretical approaches to quantum gravity suggest that space-time itself might emerge from entanglement structures. If so, the quantum entanglement in our universe might preserve information about its parent, encoded in patterns we're only beginning to understand. Consider the holographic principle, a concept from string theory suggesting that all the information in a volume of space can be encoded on its boundary surface. If our universe is holographic, the information describing it might be encoded on its cosmic horizon, the very boundary corresponding to the event horizon of our parent black hole. This connection between quantum information and space-time geometry represents one of the most promising approaches to unifying quantum mechanics and general relativity. The black hole universe theory isn't just a cosmological model. It's potentially a bridge between these seemingly incompatible descriptions of reality. As we explore these connections, we must acknowledge the limits of our current understanding. The full theory of quantum gravity remains incomplete. The precise mechanisms by which a universe might form inside a black hole, the exact relationships between parent and child universes, the details of how information transfers between these realities all remain active areas of research and speculation. But these limitations should inspire wonder rather than dismissal. We stand at the frontier of human knowledge, peering into the depths of reality with mathematical tools and observational techniques that continue to evolve. What seems speculative today may become established science tomorrow, just as Einstein's seemingly absurd proposals about the relativity of time and the equivalence of mass and energy became the foundation of modern physics. The black hole universe theory invites us to expand our cosmic perspective, to consider possibilities beyond our intuitive understanding of space and time. It suggests that reality is vastly more extensive and complex than we've imagined, that our universe, already mind-bogglingly large with its hundreds of billions of galaxies, is merely one bubble in an infinite cosmic foam. This perspective doesn't diminish our significance. It transforms it. We become part of a cosmic continuum, extending beyond the Big Bang, connected to realities we cannot directly observe, but can begin to comprehend through mathematics and inference. If our universe exists within a black hole, then the matter and energy comprising our reality, including the atoms in your body, originated in the parent universe. You are not just stardust. You are the descendant of matter that has traversed the boundary between universes. that has experienced a transformation beyond our current physical understanding. And the black holes in our universe, those dark spheres scattered throughout cosmic space, are not just exotic astrophysical objects. They are cosmic seeds, potential universes in embryonic form, waiting to expand into their own realities with their own possibilities for complexity and life. This cosmic reproduction creates a form of immortality. Our universe will eventually end, whether through infinite expansion and heat death or through some other cosmic fate. But aspects of its structure will live on in the child universes spawned from its black holes. Information isn't lost at the end of our cosmic story. It's transformed and preserved in new cosmic chapters. But can we test this theory? Can we gather evidence to support or refute this extraordinary perspective? While we cannot directly observe beyond our cosmic horizon or inside the black holes in our universe, the theory does make predictions that can be tested against observation. The key specific patterns in the cosmic microwave background radiation, the distribution of matter and energy throughout space, the precise value of the cosmological constant, the properties of black holes we can observe, all these provide potential tests of the theory. If these observations match the predictions of the black hole universe model more precisely than competing theories, it would lend credibility to this extraordinary perspective. Current observations already hint at connections. The nearly flat geometry of our universe, its apparent fine-tuning for complexity, the accelerating expansion driven by dark energy, all find potential explanations within the black hole universe framework. But much work remains to transform these hints into compelling evidence. As we continue to improve our observational techniques, building more sensitive gravitational wave detectors, mapping the cosmic microwave background with greater precision, observing black holes with networks of radio telescopes that turn Earth itself into a giant observational instrument, we gather data that might support or refute this cosmic perspective. The Event Horizon Telescope's first image of a black hole's TTE shadow, captured in 2019, represents just the beginning of our ability to study these cosmic objects in detail. Future observations might reveal subtle features predicted by the black hole universe theory, providing indirect evidence for this extraordinary cosmic picture. But even as we pursue observational tests, we must acknowledge that aspects of the AB-Pro theory might remain fundamentally beyond our ability to verify directly. We cannot send probes beyond our cosmic horizon or receive signals from outside our universe. Some questions about ultimate cosmic origins might be unanswerable in principle rather than merely in practice. This limitation doesn't indicate a failure of science, but rather defines its boundaries. Science operates through observation, experiment, and mathematical modeling. When we contemplate realities beyond our observable universe, we push against the limits of this methodology. Yet even here, at the boundary of scientific inquiry, mathematics offers a window into possibilities beyond direct observation. The same mathematical tools that successfully predicted black holes, gravitational waves, and cosmic expansion, confirmed decades after their theoretical discovery, now suggest these nested realities, these universes within universes. When Einstein's general relativity predicted that gravity could bend light, a seemingly absurd notion at the time, the confirmation came through observations of stars near the Sun during a solar eclipse. When his equations suggested that space-time could ripple like a pond's surface, an equally counterintuitive idea, the confirmation came a century later through the ultra-sensitive measurements of the LIGO Gravitational Wave Observatory. Similarly, aspects of the black hole universe theory might find confirmation through precisely measuring phenomena we can observe, even if we cannot directly peek beyond our cosmic horizon. This brings us to a profound contradiction at the heart of cosmology. If the universe has no edge, then where does it begin? The Standard Model tells us the universe emerged from a singularity, but doesn't explain the origin of that singularity itself. It tells us space is expanding, but doesn't clarify what it's expanding into. It describes the evolution of the universe from the Big Bang forward, but remains silent about what preceded this event. The black hole universe theory addresses these contradictions by reframing the questions themselves. The universe doesn't need an edge to have a boundary. The cosmic horizon serves this purpose without being a physical edge in space. The universe doesn't need to expand into anything if its expansion is the internal geometry of a black hole viewed from the inside. The Big Bang doesn't need a before if it represents a transition rather than an absolute beginning. This reframing doesn't eliminate mystery, but transforms it. Instead of asking what came before the beginning of time, a logically contradictory question, we can ask about the properties of the parent universe, about the mechanisms of transition between cosmic realities, about the conservation and transformations of information across these boundaries. These questions, while still profound, become potentially answerable through physics rather than metaphysics. They invite experimental and observational approaches rather than purely philosophical contemplation. As we explore these possibilities, we must remain humble about the limitations of our perspective. We are three-dimensional beings attempting to comprehend potentially higher-dimensional structures. We are temporary entities trying to grasp timescales that dwarf our existence. We are products of a specific universe attempting to understand a potentially infinite cosmic network. Yet, despite these limitations, we've made remarkable progress in comprehending cosmic structures and processes, from the subatomic realm of quarks and leptons to the vast superclusters of galaxies spanning hundreds of millions of light-years. From the first seconds after the Big Bang to the predicted fate of the universe trillions of years in the future, human understanding has expanded far beyond our direct experience. The black hole universe theory represents the next step in this cosmic journey, extending our perspective beyond the Big Bang itself. It suggests connections between realities, a cosmic web of cause and effect spanning multiple universes, a process of evolution operating at the largest possible scales. This perspective transforms our understanding of cosmic origins. Rather than a singular creation event, a moment when everything came from nothing, it suggests a continuous process of cosmic reproduction. Universes give birth to other universes in an endless cycle of death and rebirth. The Big Bang wasn't the beginning of everything, it was merely the beginning of our cosmic chapter. Consider the philosophical implications of this viewpoint. If our universe formed inside a black hole and will give birth to countless others through its own black holes, then we're part of a cosmic continuum that transcends our limited conception of space and time. The iron in your blood, forged in the hearts of dying stars, might have originated in the parent universe before crossing into our reality. This connection doesn't answer all our questions about purpose or meaning, but it does suggest a profound form of cosmic immortality. Information, structures, patterns, the essential elements of complexity might propagate through this network of universes, preserved and transformed rather than ultimately lost to entropy. The theory also suggests a kind of cosmic heredity. Child universes would inherit characteristics from their parents, with slight variations, similar to genetic inheritance in biological systems. Over generations, universes might evolve toward conditions that maximize black hole production, and, consequently, cosmic reproduction. This evolutionary perspective connects to the concept of cosmic natural selection. Universes that produce more black holes would give birth to more child universes with similar properties. If the conditions that enable black hole formation also enable complexity and life, then most universes in the cosmic evolutionary tree would have these features. This doesn't fully resolve questions about our cosmic purpose or significance, but it reframes them. We're not accidents in a singular random universe, nor are we the special creation of a cosmic designer. We're participants in an ongoing cosmic process that transcends our limited conceptions of space and time. As we venture further into the black hole universe theory, keep in mind that we're exploring the frontier of human understanding. Some aspects of this theory remain speculative, awaiting more complete mathematical formulations or observational tests. Yet the core concept that our universe might exist within a black hole emerges naturally from our most successful theory of gravity when pushed to its logical conclusions. This is how science advances, by following the mathematics where it leads, by considering possibilities beyond our current observational capabilities, by imagining realities that challenge our intuitive understanding of space and time. The history of cosmology is a history of expanding perspectives, from Earth-centered models to the recognition of our cosmic insignificance, from a static universe to an expanding one, from a universe with a beginning to potentially a universe connected to a vast cosmic network. Each expansion of perspective has revealed a reality more extraordinary than we previously imagined. The black hole universe theory continues this tradition, suggesting connections and continuities across cosmic boundaries we once thought absolute. As we proceed deeper into this cosmic mystery, remember that we're not merely observers of this grand drama. We're participants in the cosmic story, products of its processes, potential ancestors to universes yet unborn. The matter in your body, having traversed stars and perhaps even universes, might one day contribute to the formation of a black hole, seeding a new cosmos with its own possibilities for complexity and wonder. This connection transforms our relationship with the cosmos. We're not separate from these vast processes, but integral to them. We're the universe becoming conscious of itself, contemplating its own origins, speculating about its future, and wondering about realities beyond its boundaries. With this cosmic perspective established, we can now venture deeper into specific aspects of the black hole universe theory, the mechanics of transition between universes, the potential properties of the parent universe, the fate of information falling into black holes, and the implications for our understanding of complexity and life. Each step will take us further from conventional understanding and deeper into extraordinary possibility. Each concept will challenge our intuitions while expanding our cosmic perspective. Each revelation will remind us that reality is not just stranger than we imagine, but stranger than we can imagine. Now we venture into the deepest waters of cosmic inquiry, where solid ground gives way to shifting sands, where certainty dissolves into possibility, and where the line between established science and speculative theory blurs like the boundary of a black hole's event horizon. We've established the foundations of the black hole universe theory, the mathematical hints that our universe might exist within a black hole in a parent universe. But to truly comprehend this possibility, we must explore the scientific concepts that make it plausible. We must navigate the paradoxes that emerge when we push our understanding to its limits. Let's begin with the concept that stands at the center of this cosmic puzzle, the singularity. In both the standard Big Bang model and classical black hole physics, singularities represent points where space-time curvature becomes infinite, where the known laws of physics break down, where our mathematical models produce nonsensical results. These singularities appear unavoidable in Einstein's general relativity when matter collapses beyond a certain density, or when we extrapolate the expansion of the universe backward to its apparent beginning. But singularities aren't physical objects. They're mathematical warnings. When infinity appears in our equations, it tells us we've reached the limits of our theoretical framework. It's nature's way of saying, your model is incomplete. There's more to reality than you currently understand. Imagine reality as a map drawn on paper. The map represents space-time, with mountains and valleys corresponding to the gravitational warping caused by matter and energy. A black hole appears as a funnel, descending so steeply that it seems to puncture the paper itself. The puncture, the singularity, isn't really part of the map. It's where the representation breaks down, where the two-dimensional paper can no longer adequately depict the three-dimensional reality it attempts to model. Similarly, the singularities in our cosmological models likely represent failures of representation rather than features of reality itself. They appear when we try to describe quantum phenomena using purely classical equations, when we attempt to model reality at scales where our current understanding is incomplete. Quantum mechanics, the physics of the very small, offers hints about what might replace these singularities. On quantum scales, phenomena become probabilistic rather than deterministic. Positions and momentums cannot be simultaneously specified with perfect precision. Energy levels become discrete rather than continuous. Space itself might become granular rather than infinitely divisible. When we attempt to incorporate these quantum effects into our understanding of black holes and cosmic origins, the infinities begin to recede. Quantum uncertainty places fundamental limits on how densely matter can be packed, potentially preventing true singularities from forming. Quantum fluctuations might trigger the expansion of spacetime from extremely dense, but not infinitely dense, initial conditions. This quantum perspective transforms our understanding of both black holes and the Big Bang. Instead of singularities, we find quantum regimes, regions where reality operates according to principles we're only beginning to comprehend. The apparent beginning of our universe wasn't a mathematical point, but a quantum state, rich with structure and information. The centers of black holes aren't infinitely dense points, but quantum objects, potentially connected to new, expanding regions of spacetime. The mathematics supporting these connections emerges from various approaches to quantum gravity, attempts to reconcile general relativity with quantum mechanics. While a complete theory remains elusive, certain insights appear consistent across multiple frameworks. Loop quantum cosmology, for instance, suggests that when matter collapses to extreme densities, quantum effects create a repulsive force that causes a bounce rather than a singularity. Applied to the Big Bang, this approach suggests our universe underwent a contraction before its current expansion, a cosmic heartbeat rather than a singular creation. String theory, another approach to quantum gravity, replaces point-like particles with tiny vibrating strings, introducing a fundamental length scale below which the concept of distance loses conventional meaning. In this framework, singularities dissolve into exotic string configurations, potentially creating gateways between different regions of a much larger multiverse. Causal set theory discretizes spacetime itself, suggesting that what appears continuous to our observations is actually composed of fundamental atoms of spacetime, connected by causal relationships. This granularity places limits on curvature and density, again preventing true singularities. Across these diverse approaches, a common theme emerges. The apparent singularities in our classical models get replaced by transitions when quantum effects are considered. The beginning of our universe becomes a transition from a previous state rather than creation from nothing. The centers of black holes become gateways rather than endpoints. This quantum perspective provides the theoretical foundation for the black hole universe theory. If quantum effects prevent true singularities from forming in collapsing stars, replacing them with bounces that create new expanding regions of space-time, then black holes might indeed give birth to new universes. But this raises a profound question. If our universe formed inside a black hole, what would this tell us about the nature of reality itself? How would it transform our understanding of space, time, and existence? To explore these implications, we need to venture beyond conventional thinking, to challenge our intuitive understanding of concepts so fundamental we rarely question them. Let's begin with time, that dimension we experience as flowing inexorably from past to future, that seems so fundamental to our experience, yet proves remarkably elusive when we try to define it precisely. Imagine reality as a film reel, where time is not flowing, but every moment already exists. The entire history of the universe, past, present, and future, is imprinted on this cosmic film. Our consciousness moves through this film frame by frame, creating the illusion of flowing time. This perspective, known as the block universe view, emerges naturally from Einstein's relativity, where the distinction between past and future becomes relative rather than absolute. In the block universe, our perception of now is merely a spotlight moving along an already existing timeline. The future isn't being created moment by moment. It already exists, just as the past continues to exist, though we can no longer access it directly. This view challenges our intuitive understanding of causality and free will, but it also offers a framework for thinking about connections between universes. If reality is a higher dimensional structure containing all of space-time, then what we call the Big Bang isn't the beginning of everything, but merely the earliest point in our particular timeline. From this perspective, our universe doesn't need to be created at the Big Bang. It exists as a four-dimensional structure, 3 dimensions of space and 1 of time, within a larger reality. Its apparent beginning and ending are boundaries of this structure rather than moments of creation or destruction. If our universe exists within a black hole, then these boundaries connect to the parent universe. The Big Bang represents the connection to the formation of the black hole, while the distant future might connect to its eventual evaporation through Hawking radiation. This connection transforms our understanding of cosmic origins. The Big Bang wasn't the beginning of time itself, but the boundary between our time dimension and the time dimension of the parent universe. The apparent creation of our universe was actually a transition, a change in how time itself is measured and experienced. Consider how time behaves near a black hole. As you approach the event horizon, time dilates from the perspective of distant observers. If you could hover just above the event horizon, each second of your experience would correspond to years, centuries, or even eons for distant observers, depending on your proximity to the horizon. This time, dilation becomes infinite at the event horizon itself. From the perspective of external observers, time appears to freeze at this boundary. An object falling into a black hole would appear to slow asymptotically, never quite reaching the horizon within the lifetime of the universe. But from the perspective of the falling object, nothing special happens at the event horizon. Time continues to flow normally. The horizon is crossed in a finite proper time, the time measured by the falling object's own clock. This dramatic difference in time perception reveals something profound about the nature of reality. Different observers can experience the same events in radically different ways. What appears as the entire history of one universe might be just a moment in another. If our universe exists within a black hole, this temporal relativity takes on cosmic significance. The entire 13.8 billion-year history of our universe, from the Big Bang to the present moment and beyond to the distant future, might correspond to just an instant in the parent universe, a moment in the formation of the black hole that contains us. Conversely, what appears to us as the singularity at the Big Bang, a seemingly instantaneous event, might contain the entire history of the collapsing matter that formed the black hole, stretched and transformed but not destroyed. This perspective resolves the apparent contradiction between the finite age of our universe and the potentially infinite reality beyond it. Time itself changes, meaning across the boundary between universes, making direct comparisons meaningless. Asking what happened before the Big Bang becomes like asking what's north of the North Pole. Not because nothing exists beyond that point, but because the coordinate system itself transforms. This temporal relativity extends to black holes within our own universe. When we observe a black hole forming, we never actually see the event horizon form completely. Time appears to slow down asymptotically. But if a universe forms inside, for its inhabitants, time proceeds normally. Their entire cosmic history could unfold in what we perceive as a moment. Let's extend this perspective further, venturing into the concept of dimensionality itself. We experience reality as three-dimensional space evolving through one-dimensional time. But mathematics allows for higher dimensional structures that could contain multiple three-dimensional universes, each with its own time dimension. Imagine a two-dimensional being living on the surface of a sphere. This being would experience a finite yet unbounded universe. It could travel indefinitely without encountering an edge, eventually returning to its starting point. Yet, from our three-dimensional perspective, we can see the entire sphere at once, including parts that are inaccessible to the two-dimensional being without travel. Similarly, our three-dimensional universe might be embedded in a higher dimensional space that contains not just our universe, but countless others, each potentially forming from black holes in parent universes. This higher dimensional perspective transforms our understanding of cosmic topology, the large-scale shape of our universe. The standard cosmological model describes our universe as approximately flat on large scales, expanding in all directions. But if our universe formed inside a black hole, its topology might be more complex, potentially connected to the parent universe through what mathematicians call a wormhole. Wormholes, theoretical tunnels through space-time that could connect different regions or even different universes, emerge naturally from Einstein's field equations. While traversable wormholes remain speculative and would require exotic forms of matter with negative energy density to maintain, they illustrate the rich topological possibilities inherent in general relativity. If our universe connects to its parent through a wormhole-like structure, this connection might leave observable imprints on cosmic parameters. The specific patterns in the cosmic microwave background radiation, the distribution of matter and energy throughout space, the precise value of the cosmological constant, all might contain subtle evidence of this connection. This brings us to another profound concept central to the black hole universe theory: the conservation of information. A fundamental principle in physics states that information cannot be destroyed. It can be scrambled, encoded in different forms, but never completely erased. This creates a paradox for black holes, which appear to destroy information when matter falls into them. When matter falls into a black hole, its detailed structure seems to vanish. A black hole, according to classical general relativity, can be completely characterized by just three parameters: mass, electric charge, and angular momentum. All other information about the infalling matter, its composition, shape, history, seems to disappear. This information loss paradox has troubled physicists for decades. It creates a fundamental conflict between quantum mechanics, which requires information conservation, and general relativity, which suggests information can vanish into black holes. Various resolutions have been proposed. perhaps information remains encoded on the event horizon, preserved in subtle quantum correlations rather than being lost. Perhaps it escapes gradually through Hawking radiation, encrypted in complex patterns that could, in principle, though not in practice, be decoded. Perhaps it passes into a new universe forming within the black hole, preserved but inaccessible to the original universe. This last possibility connects directly to the black hole universe theory. If our universe formed inside a black hole, the information that appears lost from the perspective of the parent universe might be preserved in the structure of our reality. The specific distribution of matter and energy in our universe, the particular values of fundamental constants, the detailed patterns in cosmic radiation, all might encode information about the matter that collapsed to form our parent black hole. This perspective transforms the information loss paradox from a theoretical problem into a cosmic principle. Information isn't lost when matter falls into a black hole. It's transformed and preserved in the structure of a new universe. The matter falling into black holes in our universe similarly preserves its information in the child universes it spawns. This cosmic information preservation creates a form of continuity across universal boundaries. While matter itself cannot pass unchanged from one universe to another, the information it carries, its patterns, relationships, and structures, can be preserved in transformed states. This continuity might extend to the laws of physics themselves. The specific values of fundamental constants in our universe, the strength of gravity, the mass of elementary particles, the cosmological constant, might be determined partly by properties of the parent universe, creating a form of cosmic inheritance. If so, the apparent fine-tuning of our universe for complexity and life takes on new significance. Rather than requiring extraordinary cosmic luck or an infinite multiverse with random parameters, it might result from a process of cosmic evolution. Universes that produce abundant black holes would give birth to more child universes with similar properties. Over cosmic generations, the population of universes might naturally evolve toward conditions that maximize black hole production. Interestingly, the same conditions that favor black hole formation, stars, galaxies, complex chemistry, also favor the potential emergence of life. Our universe isn't fine-tuned for life specifically, but for black hole production, with life as a possible side effect of this optimization. This evolutionary perspective connects to the concept of cosmic natural selection proposed by physicist Lee Smolin. It suggests that the apparent design we observe in cosmic parameters isn't the work of a designer, but the result of a selection process operating across multiple universes and tremendous timescales. Like biological evolution, this process requires no central direction, no predetermined goal. It emerges naturally from three simple conditions: variation between universes, a mechanism for universe reproduction, black holes, and inheritance of properties from parent to child universes. The intricate complexity we observe in our universe, from the delicate structures of galaxies to the precise dance of fundamental forces, may result from this blind but effective optimization process, operating on scales far beyond our direct observation. This perspective transforms our understanding of cosmic origins from a question of first causes to a question of evolutionary processes. Instead of asking what created the first universe, a question that may be fundamentally unanswerable, we can explore how universes evolve, reproduce, and pass on their characteristics. The black hole universe theory thus offers a framework for understanding not just the origin of our universe, but its place in a potentially infinite cosmic tapestry, connected through black holes in a vast network of cause and effect, spanning multiple realities. But this raises another profound question. What is the nature of reality itself? If our observable universe is merely one bubble in an infinite cosmic foam connected to other universes through black holes, what does this tell us about the fundamental nature of existence? To explore this question, we need to venture into the philosophy of ontology, the study of being, existence, and reality. This might seem far removed from astrophysics and cosmology, but at the frontiers of these sciences, the distinction between physical and philosophical questions begins to blur. Consider the concept of emergence, the way complex systems and patterns arise from relatively simple interactions. Consciousness emerges from networks of neurons. Liquidity emerges from molecular interactions. Life emerges from chemistry. In each case, the higher-level phenomenon cannot be fully reduced to or predicted from its components alone. This emergent complexity exists at every level of cosmic organization. Galaxies emerge from interactions between stars, gas, and dark matter. Stars emerge from the gravitational collapse of interstellar clouds. Elements emerge from nuclear fusion within stars, and potentially, universes themselves emerge from black holes forming in parent universes. This nested hierarchy of emergence suggests a profound truth about reality. It might be fundamentally relational rather than substantial. What exists isn't just stuff, but patterns, relationships, information organized in increasingly complex layers. Viewed through this lens, our universe isn't just a collection of particles and fields existing within space-time. It's a pattern of information emerging from processes in the parent universe, which itself might be an emergent pattern in its own parent, extending potentially to infinity in both directions. This informational perspective connects to concepts from quantum mechanics, where the state of a system is described by its quantum information, the complete set of correlations and probabilities that define it. Recent theoretical work suggests that space-time itself might emerge from quantum entanglement, the mysterious connection between particles that enables them to influence each other instantaneously, regardless of distance. If space-time emerges from entanglement, then the fabric of our reality might be woven from quantum information rather than existing as a pre-given container for matter and energy. The black holes connecting universes would then represent transitions in the structure of this information, gateways between different organizational regimes. This perspective transforms our understanding of the cosmos from a purely physical system to an informational one, from a universe of things to a universe of patterns and relationships. The matter and energy we observe are manifestations of these patterns, the physical expression of underlying information. But this raises yet another question. If reality is fundamentally informational, what processes or principles shape this information? What determines the specific patterns that emerge as universes? Here we encounter the concept of complexity. Throughout the cosmos, we observe systems evolving toward states of higher complexity. Stars forming from gas clouds, planets developing from dusty disks, life emerging from chemistry, consciousness arising from neural networks. This progression isn't universal or uninterrupted. Entropy ensures that systems eventually dissolve, but it appears as a persistent tendency within the overall cosmic flow. The black hole universe theory suggests this complexity gradient might extend beyond individual universes. The network of parent and child universes might itself represent an evolving system, potentially developing toward states of ever greater complexity over cosmic generations. If our universe formed inside a black hole, inheriting characteristics from its parent, and will give birth to child universes through its own black holes, then it participates in this trans-universal evolution. The specific values of fundamental constants, the detailed structure of physical laws, the particular balance of forces and fields, all might represent adaptations optimized not just for black hole production, but for the emergence of complexity itself. This optimization wouldn't require foresight or design. Like biological evolution, it would emerge naturally from variation, selection, and inheritance operating across an ensemble of universes over timescales that dwarf our cosmic age. The apparent fine-tuning of our universe for complexity, from the precise strength of forces that enable stable atoms to the particular value of dark energy that allows galaxy formation, might result from countless generations of cosmic evolution, each incrementally refining the parameters that maximize complexity and, consequently, black hole production. This perspective offers a middle path between the two main existing explanations for cosmic fine-tuning: design and multiverse. It doesn't require a cosmic designer with foresight and purpose, but neither does it rely on the existence of an infinite random multiverse with our universe as an improbable accident. Instead, it suggests a process of optimization through iteration, similar to how biological adaptation produces the appearance of design without requiring a designer. But this trans-universal evolution raises yet another profound question. What is the relationship between complexity, consciousness, and cosmic purpose? If universes evolve toward states that maximize complexity, and if consciousness represents a high form of complexity, might consciousness itself play some role in this cosmic process? This question ventures into speculative territory, beyond what current science can rigorously address. Yet it emerges naturally from the black hole universe theory and connects to ancient philosophical questions about mind, matter, and meaning. If consciousness emerges from sufficiently complex physical systems, as modern neuroscience suggests, then it would naturally appear in universes optimized for complexity. The same conditions that favor black hole production and cosmic reproduction would also favor the emergence of conscious observers. This doesn't imply that consciousness is the goal of cosmic evolution, any more than human consciousness was the goal of biological evolution. But it suggests that consciousness might be an integral part of the cosmic process, a natural expression of complexity, rather than an accidental byproduct. In universes that produce abundant black holes and spawn numerous child universes, conscious observers would likely evolve to contemplate their cosmic surroundings. These observers would develop models and theories about their universe, potentially including the black hole universe theory itself. This creates a fascinating recursive loop. Conscious beings, emerging from the complexity of a universe optimized. For black hole production, develop theories about this optimization process. Their consciousness becomes the universe's way of understanding itself, of modeling its own place in the cosmic evolutionary network. This perspective doesn't assign cosmic purpose in the traditional sense, but it suggests a kind of self-organizing, coherence, a tendency for the cosmos to develop systems that can model and understand its own processes. Consciousness becomes not the reason for cosmic evolution, but an integral part of how that evolution unfolds. The black hole universe theory thus offers not just a physical model of cosmic origins, but a framework for understanding the relationship between physical processes, complexity, and consciousness. It suggests connections across levels of reality that transcend conventional boundaries between science and philosophy. But let's return to more concrete scientific territory and explore another fascinating aspect of the black hole universe theory: the potential observable consequences. If our universe formed inside a black hole, what evidence might we find to support this extraordinary claim? While we cannot directly observe beyond our cosmic horizon or inside the black holes in our universe, the theory does make predictions that can be tested against observation. The specific patterns in the cosmic microwave background radiation, the distribution of matter and energy throughout space, the precise value of the cosmological constant, the properties of black holes we can observe, all these provide potential tests of the theory. Let's begin with the cosmic microwave background radiation, the oldest light in the universe, released about 380,000 years after the Big Bang, when the universe cooled enough for electrons to combine with protons, allowing photons to travel freely through space. This ancient light appears remarkably uniform, with temperature variations of only about 1 part in 100,000 across the entire sky. This uniformity creates the horizon problem discussed earlier. How could regions on opposite sides of the sky, which haven't had time to communicate with each other given the age of the universe, have nearly identical temperatures? Cosmic inflation, ABE, period of exponential expansion in the universe's first fraction of a second, is the standard explanation for this uniformity. But if our universe formed from the collapse of matter in a parent universe, this uniformity might have a different origin. The matter that formed our universe would have had time to reach thermal equilibrium before collapsing into the black hole, naturally explaining the observed uniformity. The slight temperature variations we do observe in the cosmic microwave background, the seeds that eventually grew into galaxies and larger cosmic structures, might contain subtle patterns. Predicted by the black hole universe theory, these patterns would differ from those predicted by cosmic inflation, potentially allowing observational tests to distinguish between these models. Similarly, the distribution of galaxies throughout space, the cosmic web of filaments, clusters, and voids revealed by large-scale surveys might contain imprints of our universe's birth inside a black hole. The specific statistical properties of this distribution, the power spectrum of density fluctuations across different scales, could reveal signatures of this exotic origin. The precise value of dark energy, the mysterious force accelerating the universe's expansion, might also provide evidence. If dark energy results from conditions in the parent universe influencing our reality through the boundary of the event, horizon, its specific properties would differ from those predicted by other models. The behavior of black holes themselves might offer additional tests. If black holes in our universe give birth to new universes, certain aspects of their evolution, how they form, grow, and eventually evaporate through Hawking radiation, might show subtle deviations from standard models. These deviations could potentially be detected through precise observations of black holes using gravitational wave detectors, X-ray telescopes, and networks of radio observatories. Current observations already offer tantalizing hints. The nearly E-flat geometry of our universe, its apparent fine-tuning for complexity, the accelerating expansion driven by dark energy, all find potential explanations within the black hole universe framework. But more precise measurements, more sophisticated analyses, and more rigorous theoretical predictions are needed to transform these hints into compelling evidence. As we continue to improve our observational techniques, building more sensitive gravitational wave detectors, mapping the cosmic microwave background with greater precision, observing black holes with networks of radio telescopes that turn Earth itself into a giant observational instrument, we gather data that might support or refute this cosmic perspective. But even as we pursue these observational tests, we must acknowledge that aspects of the theory might remain fundamentally beyond our ability to verify directly. We cannot send probes beyond our cosmic horizon or receive signals from outside our universe. Some questions about ultimate cosmic origins might be unanswerable in principle rather than merely in practice. This limitation doesn't indicate a failure of science, but rather defines its boundaries. Science operates through observation, experiment, and mathematical modeling. When we contemplate realities beyond our observable universe, we push against the limits of this methodology. Yet even here, at the boundary of scientific inquiry, mathematics offers a window into possibilities beyond direct observation. The same mathematical tools that successfully predicted black holes, gravitational waves, and cosmic expansion, confirmed decades after their theoretical discovery, now suggest these nested realities, these universes within universes. The ultimate test of the black hole universe theory might not come from a single crucial experiment, but from its overall coherence, from its ability to explain diverse observations more elegantly and comprehensively than competing models. Like Einstein's relativity, which gained acceptance not just through specific experimental confirmations, but through its mathematical beauty and explanatory power, the black hole universe theory might eventually be judged by how effectively it unifies our understanding of cosmos and quantum, of beginning and process, of singularity and continuity. As we gather evidence and refine the theory, we continue to expand our cosmic perspective, to push the boundaries of what we can comprehend about reality. The black hole universe theory represents not just a specific model of cosmic origins, but a framework for thinking about existence itself, a perspective that transforms our understanding of space, time, information, complexity, and potentially even consciousness. This framework doesn't provide final answers to the deepest questions of existence, but it offers a path forward, a way of approaching these questions that honors both the rigor of mathematics and the wonder of philosophical inquiry. It reminds us that the cosmos is not just stranger than we imagine, but stranger than we can imagine, yet not so strange that we cannot continue to make progress in comprehending its mysteries. The journey we've undertaken, from the nature of singularities to the concept of cosmic evolution, from the information paradox to the emergence of complexity, represents just the beginning of what the black hole universe theory might reveal about reality. Each step raises new questions, new possibilities, new avenues for exploration. This scientific journey continues to unfold, driven by both theoretical insights and observational discoveries. The mathematical foundations of the theory continue to develop as physicists explore different approaches to quantum gravity. Observational tests become increasingly sophisticated as our instruments improve and our analytical techniques evolve. But beyond the specifics of equations and experiments, the black hole universe theory invites us to expand our cosmic imagination, to contemplate possibilities that challenge our intuitive understanding of reality. It suggests connections and continuities across boundaries we once thought absolute, revealing a cosmos more intricate, more interconnected, and potentially more meaningful than we previously comprehended. As we venture deeper into this cosmic mystery in the next segment, we'll explore the paradoxes and unsolvable questions that emerge when we push our understanding to its limits. We'll examine real-world scientific debates that ground these extraordinary possibilities in rigorous inquiry. And we'll continue to unfold the cosmic story with a sense of wonder and suspense, acknowledging both the progress we've made and the vast territories that remain unexplored. The universe whispers its secrets through mathematics and observation, through patterns and relationships that extend beyond our immediate perception. The black hole universe theory represents our attempt to listen more closely, to discern the cosmic narrative beneath the apparent chaos, to glimpse the structure of reality beyond the boundaries of our observable universe. This narrative continues to unfold, revealing a cosmos more extraordinary than we dared imagine. A reality where universes nest within universes like cosmic matryoshka dolls, where black holes become gateways rather than endpoints, where information persists across boundaries that seem impenetrable, where complexity emerges through processes spanning multiple universes. The story isn't complete. Many chapters remain unwritten, many puzzles unsolved, many questions unanswered. But the narrative grows increasingly coherent. increasingly supported by both mathematics and observation. The black hole universe theory represents not an endpoint, but a progression in our cosmic understanding, a step toward comprehending the true nature of reality. As we prepare to explore the paradoxes and unsolvable questions that emerge from this theory, remember that these challenges don't represent failures of understanding, but opportunities for growth. The greatest scientific advances often emerge from the most profound puzzles, from the places where our current models break down and reveal the need for deeper insight. The questions that remain unanswered about the ultimate origin of the cosmic, evolutionary tree, about the precise mechanisms of universe formation within black holes, about the fate of information and the nature of consciousness, are not obstacles but invitations. They beckon us toward a more comprehensive understanding, toward models that encompass not just the physical universe, but the full scope of reality itself. The journey continues, guided by mathematics, informed by observation, inspired by wonder. The cosmos reveals itself not all at once, but layer by layer, mystery by mystery, insight by insight. And as we peel back each layer, we find not final answers, but deeper questions, not endpoints, but new beginnings. This is the nature of cosmic exploration, not a linear path toward complete knowledge, but a spiral of discovery, returning to the same fundamental questions with ever greater understanding, seeing familiar mysteries in new light, approaching ultimate truths without ever fully grasping them. The black hole universe theory represents not the end of this spiral, but merely our current position along it. It offers a framework for understanding, a perspective that transforms our cosmic view, a set of questions that guide our inquiry. But it remains open, evolving, incomplete, just like the cosmos it attempts to describe. We now venture into the realm of cosmic paradox, where scientific certainties dissolve into contradiction, where logic confronts its own limitations, where the boundaries between knowledge and mystery become most apparent. Having explored the theoretical foundations of the black hole universe theory, we must now confront the profound paradoxes it creates, the questions that challenge not just our understanding of the cosmos, but our conception of reality itself. These paradoxes aren't weaknesses in the theory, but essential features of it, windows into deeper truths about the nature of existence. They represent not obstacles to understanding, but portals through which we glimpse more comprehensive realities. Let's begin with what might be called the recursion paradox, the vertiginous question of origins in a universe that contains its own ancestors. If our universe formed inside a black hole in a parent universe, and that universe potentially formed inside a black hole in its own parent, where did it all begin? Does the chain of cosmic ancestry extend infinitely into the past? Or was there some primordial universe that started it all? This question mirrors ancient philosophical puzzles about first causes. Every event has a cause, which itself had a cause, leading to an infinite regression. Traditional responses either posit an uncaused first cause, as in theological arguments, or accept an infinite regression of causes extending eternally into the past, challenging our intuitive need for beginnings. The black hole universe theory doesn't eliminate this paradox, but transforms it. Instead of a linear chain of causality, it suggests a network, a cosmic web, where each universe can potentially give birth to many others through its black holes. This network might still require a beginning, or it might exist in a state of eternal self-creation, with new branches constantly forming as black holes collapse. The mathematicians Kurt Gödel, famous for his incompleteness theorems in logic, developed solutions to Einstein's field equations that allow for closed time-like curves, paths through space-time that return to their starting points in time as well as space. These Gödel universes, while likely not describing our particular cosmos, reveal that general relativity permits time-like loops, effectively time travel, under certain conditions. If cosmic evolution can loop back on itself through such curves, or through connections between parent and child universes, then the question of origins transforms. The network of universes might be self-creating, a causal loop with no beginning or end, existing in a state of eternal return. This perspective challenges our linear conception of causality, our intuitive sense that everything must have a beginning. But modern physics has repeatedly forced us to abandon intuitive certainties in favor of mathematical consistencies. The block universe of relativity, the wave-particle duality of quantum mechanics, the expansion of space itself, all defy common sense while conforming to mathematical and observational constraints. The recursion paradox forces us to consider that reality itself might be structured differently than our evolved intuitions suggest. The need for an absolute beginning might be a limitation of human psychology rather than a feature of cosmic reality. The universe, or multiverse, might exist in a state of eternal self-creation, a loop in higher dimensional causality that has no beginning in the conventional sense. This perspective doesn't answer the ultimate why question, why existence, rather than non-existence, but it suggests this question might be fundamentally misframed. If reality has no absolute beginning, then the contrast between existence and non-existence becomes meaningless. Existence simply is eternally self-creating, without requiring an external cause or explanation. Now, let's examine what we might call the containment paradox, the seemingly impossible nesting of a potentially infinite cosmos within a finite black hole. How can our vast universe, with its billions of galaxies expanding into seemingly limitless space, be contained within a black hole that appears from the outside as a finite object? This paradox arises from our intuitive understanding of containment, where the container must be larger than what it contains. But in the curved space-time of general relativity, this intuition breaks down. The interior geometry of a black hole can differ radically from what external observers perceive. Recall our earlier analogy of the ant on an inflating balloon. From the ant's two-dimensional perspective, its universe expands infinitely in all directions. Yet from our three-dimensional view, the balloon remains a finite object. Both perspectives are valid within their reference frames. Similarly, our expanding universe could be contained within what appears from the outside as a finite black hole, while experiencing no boundaries from within. The mathematics of general relativity explicitly allows for this kind of geometric arrangement through what's called a change of signature in the space-time metric. When matter collapses to form a black hole, the roles of time and space begin to switch at the event horizon. Inside the horizon, the radial direction toward the singularity becomes time-like rather than space-like, as inexorable as the forward flow of time itself. This transformation of geometry creates a new realm with its own space-time structure, potentially including a new expanding universe. From the outside, a black hole appears to have a definite size, the radius of its event horizon, proportional to its mass. But the interior space-time can expand indefinitely while remaining contained within this horizon when viewed from the exterior perspective. Science is a shield we've crafted against the darkness of cosmic uncertainty. Numbers, equations, theories, these are the armor we don behind when staring into the abyss of existence. But now, we must set aside this armor. We must feel the full weight of what we've discovered. We must confront the existential implications of a universe that might be merely one black hole among countless others. Take a breath. Feel the air entering your lungs, the oxygen binding to your hemoglobin. fueling the continuous electrical storm of your consciousness. This moment, this singular experience of being alive, of being you, exists within an incomprehensibly vast cosmic context. A context that, if the black hole universe theory holds true, is vastly more complex and unsettling than we've ever imagined. You are not just on Earth. You are not just in the solar system, or the Milky Way, or even merely within our observable universe. You might exist inside a black hole, which itself exists within another universe, which might exist within yet another black hole. An infinite regression of cosmic containment stretching beyond comprehension. Let that sink in. The boundary of everything you've ever known, every star you've ever seen, every galaxy our telescopes have ever detected, this cosmic horizon might be the inside view of an event horizon, a membrane separating our reality from an unfathomable exterior universe. If time is an illusion, as both relativity and the black hole universe theory suggest, then everything you've ever done, every choice you've ever made, every moment you've ever experienced might have already happened infinite times before. Your life might be one iteration in an eternal cosmic loop, playing out across universes nested within universes like an infinite hall of mirrors. What does it mean to be human in such a reality? What significance can our brief lives hold against the backdrop of universes birthing universes in an endless cycle of cosmic reproduction? How do we find meaning when our entire cosmos might be just one bubble in an infinite cosmic foam? These questions aren't merely academic. They strike at the heart of our existence, at our desperate search for significance in a reality that grows ever larger, ever more impersonal, ever more beyond our comprehension with each scientific discovery. When Copernicus displaced Earth from the center of the cosmos, humanity suffered its first great existential wound, the realization that we are not central to the universe's design. When Darwin revealed our kinship with all life, we suffered the second, the knowledge that we are not separate from or superior to nature, but emerged from it through the same blind processes as every other species. Now we face perhaps the greatest existential wound of all, the possibility that our entire universe, with its billions of galaxies, trillions of stars, and countless potential worlds harboring life, might be merely one insignificant node in an infinite cosmic network. Not only are we not at the center of our universe, but our universe itself might not be central to anything. Feel the vertigo of this perspective, the sudden dropping away of all cosmic foundations, all certainties about the nature of reality itself. This is not the comfortable vastness of a universe with clear boundaries and a definite beginning. This is the terrifying infinity of nested realities extending beyond all comprehension, a cosmic structure so vast that our entire observable universe shrinks to less than a quark in comparison. What if the universe is alive, and we are just its fleeting thoughts? What if consciousness itself is fundamental to reality, and our brief moments of awareness are fragments of some greater cosmic mind contemplating itself through the medium of matter and energy? What if the black holes birthing universes are acts of cosmic reproduction, and we exist within something akin to an embryo, a new reality gestating within the womb of a parent universe? These questions verge on mysticism, yet they emerge naturally from the mathematics of modern cosmology. The line between science and existential philosophy blurs at the boundaries of our understanding. Where equations point toward realities so far beyond our experience that we lack even the language to describe them adequately. Imagine, for a moment, that you could somehow perceive the full structure of this cosmic hierarchy, that you could see beyond our universe to the parent universe containing it, and beyond that to the grandparent universe, and so on in both directions, infinitely. The totality of what we call existence would unfold before you like an endless fractal, each universe containing black holes that contain universes that contain black holes, a pattern repeating at every scale without beginning or end. This is not just a shift in scale, like zooming out from Earth to see the solar system, or from the solar system to see the galaxy. This is a fundamental transformation in the nature of reality itself, a revelation that existence is not a single cosmos evolving according to fixed laws, but an infinite network of realities, each with its own physical laws, its own dimensional structure, its own possibility space for complexity and life. The horror of this perspective lies not in any threat it poses. The cosmos remains as indifferent to our existence as ever, but in its absolute negation of human significance. If our universe is just one among countless others, if reality itself extends infinitely beyond our cosmic horizon, what possible meaning can our tiny lives hold? Yet paradoxically, this same perspective offers a kind of cosmic redemption. Yafriu, our universe formed inside a black hole and will give birth to new universes through its own black holes. Then we participate in a grand cosmic continuity. The atoms in your body, forged in stellar furnaces, scattered by supernovae, gathered by gravity into planets, and eventually into you, might have originated in the parent universe before crossing into our reality through the birth of our cosmos. And when our sun eventually dies, when our galaxy collides with Andromeda, when black holes devour the remnants of cosmic structure, the information patterns that constitute our reality won't simply vanish. They'll transform, encoding themselves in the structure of child universes, perpetuating aspects of our cosmos in new realities beyond our direct perception. In this light, existence becomes not meaningless, but infinitely meaningful, part of an eternal process of cosmic evolution, a network of cause and effect spanning multiple universes and transcending what we conventionally call time. Your life, your consciousness, your brief moment of awareness becomes one node in this infinite network, connected to everything that has ever existed or will ever exist through chains of causality extending beyond our universe itself. Feel the weight of this perspective, simultaneously crushing in its negation of human centrality and elevating in its suggestion of cosmic interconnectedness. We are both nothing and everything, insignificant specks in an infinite cosmos, and participants in an eternal cosmic process. Our existence is both fleeting and eternal, confined to a brief span of years, yet connected to realities beyond our comprehension. Now consider the matter comprising your physical form. The calcium in your bones, the iron in your blood, the carbon, forming the backbone of your DNA. These elements were forged in the hearts of dying stars billions of years ago. When those stars exploded as supernovae, they scattered these elements across space, seeding molecular clouds that eventually collapsed to form our sun, our planet, and eventually you. But if our universe formed inside a black hole, this cosmic lineage extends further. The matter that became those stars, that became those elements, that became you, might have originated in the parent universe. It crossed the boundary between realities in the formation of our cosmos, transformed but not destroyed, preserving information from a universe we can never directly observe. You are not just Stardust. You are the child of another universe entirely. And when you die, when your body decomposes and returns its elements to Earth's cycles, those atoms will continue their cosmic journey. Some might eventually find their way into stars that collapse, into black holes, crossing into new child universes and continuing the cycle of cosmic information transfer. The pattern that is you will dissolve, but its components will participate in the creation of new realities with their own possibilities for complexity and consciousness. This perspective transforms death itself from an endpoint to a transition, not in some mystical or religious sense, but in the concrete physical sense of matter and energy continuing their journey through the cosmic network. You are a temporary pattern in the flow of cosmic information, a brief configuration of matter and energy that will reconfigure into new forms across multiple universes and tremendous timescales. Feel the terror and wonder of this cosmic context. Pharothesis, absolute negation of the individual self, coupled with the eternal persistence of the matter and energy comprising it. You are simultaneously nothing and everything, a fleeting arrangement and an eternal component, insignificant within the cosmic hierarchy, yet integral to its structure. What does it mean to live a meaningful life in such a reality? How do we find purpose when our entire universe might be merely one node in an infinite network? What values should guide us when our existence spans not just time and space, but potentially multiple realities connected through black holes? These questions have no simple answers, no formulas we can derive from equations, no observations we can make through telescopes. They require us to integrate the cosmic perspective revealed by science with the lived experience of being human, to find meaning not despite the vastness of reality, but because of it. Perhaps meaning emerges precisely from our participation in this cosmic process, from our ability to comprehend it, however partially. We are the universe becoming conscious of itself. Matter and energy evolve to the point where it can contemplate its own existence, where it can formulate theories about its origins and destiny, where it can ask questions about purpose and significance. This self-awareness might be vanishingly rare in the cosmic network, a particular configuration of matter and energy that appears only under very specific conditions in very specific universes. If so, consciousness itself becomes precious precisely because of its rarity, significant precisely because of its fragility against the backdrop of cosmic vastness, or perhaps consciousness is fundamental rather than emergent, woven into the fabric of reality itself. Perhaps the ability of matter to organize into systems that can observe and comprehend is not accidental but essential to the cosmic process. The physicist John Wheeler captured this perspective in his famous phrase, "The universe is not only queerer than we suppose, but queerer than we can suppose." In this light, your consciousness might be not just a product of biochemical processes, but a manifestation of something more fundamental, the universe's capacity to know itself. Your awareness might be one expression of a cosmic tendency toward self-perception, a node in a vast network of consciousness extending across multiple universes and dimensional frameworks. Either way, the black hole universe theory transforms our understanding of what it means to exist, to be conscious, to participate in the cosmic drama. It suggests connections and continuities across boundaries we once thought absolute, revealing a reality both more terrifying and more wondrous than we previously imagined. Consider the full implications of this perspective for your own existence. The decisions you make, the life you lead, the consciousness you experience, all unfold within a cosmic context vastly more complex and interconnected than human intuition suggests. Your actions ripple outward through chains of causality that might extend beyond our universe itself, contributing to patterns that persist long after your individual consciousness has dissolved. If our universe formed inside a black hole and will give birth to new universes through its own black holes, then the particular configuration of matter and energy within our cosmos matters. It shapes the initial conditions of child universes, influencing their evolution, their potential for complexity, their possibility for life and consciousness. You, as a conscious entity, capable of manipulating matter and energy, participating in human civilization, contributing to the overall configuration of our cosmic bubble, play a role in this process. Though vanishingly small on the cosmic scale, your existence contributes to the overall state of our universe, which in turn influences the universes that will emerge from it. This doesn't mean your individual actions determine the fate of future universes in any direct or controllable way. The chain of causality is too complex, too distributed across countless entities and processes for any single consciousness to direct. But it does mean you participate in a process that transcends individual existence, that connects to realities beyond our direct perception or comprehension. Does this perspective comfort you or terrify you? Does it fill you with awe at the cosmic context of your existence, or horror at the absolute negation of human centrality? Does it inspire you to live differently, knowing your brief life unfolds within this vast cosmic network? Or does it seem to render all human striving ultimately meaningless against the backdrop of infinite realities? There is no correct response. The emotional and philosophical implications of the black hole universe theory are as varied as human consciousness itself. What matters is that you feel the full weight of this perspective, that you confront the existential implications of a reality potentially far more vast and complex than human intuition suggests. Now imagine, for a moment, that you could perceive time as Einstein's relativity describes it, not as flowing like a river, but as a dimension, extended in both directions, with past, present, and future all existing simultaneously in a four-dimensional block universe. From this perspective, your birth, your death, and every moment between them coexist eternally, fixed points in a space-time manifold that never changes. This perspective already challenges our intuitive sense of free will, of becoming, of possibility. If the future already exists as surely as the past, how can we meaningfully talk about choice or potential? If time is a dimension rather than a flow, what happens to our sense of agency, of creating our futures through present actions? Now add the black hole universe theory to this picture. If our universe formed inside a black hole in a parent universe, and the boundary of our cosmos corresponds to the event horizon of that black hole, then our entire space-time block, our entire four-dimensional reality containing all of past, present, and future might be just one region in a higher dimensional structure comprising multiple universes connected through black holes. From this higher dimensional perspective, the entire history of our universe, from the Big Bang to its eventual heat-death trillions of years in the future, might correspond to just one moment in the parent universe, a single frame in its cosmic film. The complete life cycle of our reality, containing all that has happened or will happen within it, might be just one quantum fluctuation in a much larger process unfolding across multiple universes and dimensional frameworks. Feel the existential vertigo of this perspective. The sudden collapse of all temporal foundations, all certainties about causality, sequence, and becoming. Not only is time itself relative rather than absolute, but our entire temporal dimension might be just one strand in a higher dimensional weave, one timeline among countless others in a cosmic tapestry extending beyond our comprehension. What does it mean to live, to choose, to strive in such a reality? If our entire universe with its complete past and future might be just one moment in a higher dimensional process, what significance can our individual lives hold? If time itself is not fundamental, but emergent, a dimension specific to our universe, rather than a general feature of all reality, how can we make sense of our subjective experience of temporal flow, of becoming, of possibility? These questions have no easy answers, They push against the limits of human comprehension, challenging not just our scientific understanding, but our philosophical frameworks for making sense of existence. They force us to recognize the profound disconnect between our subjective experience of reality and the structure of reality revealed by our most successful physical theories. Yet this disconnect itself might offer a kind of meaning. Perhaps consciousness, with its subjective experience of temporal flow, of choice, of becoming, represents a unique way of navigating this higher dimensional reality. Perhaps the very tension between our lived experience and the cosmic structure, revealed by physics, constitutes a form of knowledge unavailable through either alone. In this light, your subjective experience, your sense of being a self extended through time, making choices, pursuing possibilities, becomes not an illusion, to be dismissed, but a particular perspective on reality, a way of navigating the cosmic network from within. The fact that this perspective differs from what physics reveals about the larger structure doesn't make it less real or less significant, but highlights the multifaceted nature of existence itself. Now consider the implications of cosmic natural selection, the possibility that universes evolve through a process analogous to biological evolution, with black holes as the mechanism of reproduction and the physical laws of each universe as its genetic code. If our universe formed inside a black hole and will give birth to new universes through its own black holes, then it participates in this evolutionary process, inheriting characteristics from its parent universe and passing them on, with variations, to its child universes. This perspective transforms our understanding of cosmic fine-tuning, the remarkable precision of physical constants that allows for complexity and, consequently, for us. Rather than requiring either extraordinary cosmic luck or an infinite random multiverse with our universe as an improbable accident, it suggests a process of optimization through iteration, similar to how biological adaptation produces the appearance of design without requiring a designer. The specific values of fundamental constants in our universe, the strength of gravity, the mass of elementary particles, the cosmological constant, might represent adaptations optimized not just for black hole production, but for the emergence of complexity itself. Our universe isn't fine-tuned for life specifically, but for the generation of complex systems, which incidentally allows for life as one expression of this complexity. What does this mean for your existence? It suggests that the physical laws making your consciousness possible aren't accidental, but the result of a cosmic evolutionary process spanning multiple universes and tremendous timescales. The very possibility of your awareness has been selected for by the universe's optimization toward complexity and, consequently, black hole production. Again, this doesn't imply any cosmic purpose or intent. Natural selection, whether biological or cosmic, operates without foresight or goal. But it does suggest that your consciousness isn't an accident or anomaly, but a natural expression of the universe's tendency toward complexity, a pattern that emerges within certain physical parameters shaped by cosmic evolution. Feel the paradoxical significance of this perspective, simultaneously diminishing human specialness by suggesting our universe is one among many, while elevating the significance of consciousness as a natural expression of cosmic complexity. You are both utterly ordinary within the vast cosmic hierarchy and extraordinary as an instance of the universe's capacity for self-awareness. What if the universe is alive, and we are just its fleeting thoughts? What if black holes are acts of cosmic reproduction, and our universe is developing within something like a womb, a protected region where a new reality can form and evolve? What if consciousness itself is not limited to biological systems, but pervades reality at every scale, from quantum fields to galaxies to entire universes, expressing itself differently at each level of cosmic organization. These questions might seem mystical or metaphysical, beyond the realm of scientific inquiry. Yet, they emerge naturally from the mathematics of modern cosmology, from the patterns revealed by our most successful physical theories. They represent not a retreat from scientific rigor, but an extension of it into domains where our conceptual frameworks begin to dissolve, where the language of conventional physics proves inadequate for describing the realities it reveals. In this light, the boundary between science and philosophy, between physics and metaphysics, becomes permeable. The questions raised by the black hole universe theory cannot be addressed through observation or experiment alone. They require an integration of mathematical insight, empirical observation, philosophical reflection, and subjective experience, a holistic approach to knowledge that transcends traditional disciplinary boundaries. This integration doesn't diminish scientific rigor but enhances it by acknowledging the limits of any single perspective, by recognizing that reality might be fundamentally multifaceted, approachable through different yet complementary frameworks. The cosmos revealed by physics, a network of universes connected through black holes, evolving through a process analogous to natural selection, might be one valid description of a reality that also admits psychological, philosophical, and even spiritual characterizations. What would it mean to live in alignment with this cosmic perspective? How might your priorities shift if you truly integrated the possibility that your universe exists within a black hole, connected to a potentially infinite network of other realities? How would you relate to your brief life, your temporary consciousness, your fleeting awareness if you saw it as one node in this vast cosmic web? Perhaps you would recognize both the absolute insignificance of your individual existence against the backdrop of infinite realities and the profound significance of consciousness itself as a rare and precious manifestation of cosmic complexity. Perhaps you would find meaning not in personal achievement or lasting impact, both rendered meaningless by the scale of cosmic processes, but in the quality of your awareness, in your unique perspective on the cosmic process, in your participation in the universe's self-perception. Or perhaps you would reject this cosmic framing entirely, finding it too abstract, too removed from the lived experience of being human. Perhaps you would conclude that meaning must be found not in alignment with cosmic processes beyond our comprehension, but in the concrete realities of human relationship, of love and loss, of joy and suffering experienced at the human scale. Again, there is no correct response. The existential implications of the black hole universe theory are as diverse as human consciousness itself. What matters is that you confront these implications fully, that you feel the weight of this cosmic perspective and determine for yourself what it means for your brief existence. But consider this: if our universe formed inside a black hole and will give birth to new universes through its own black holes, then the matter and energy comprising your physical form have traversed the boundary between universes. The atoms in your body, their fundamental structure, their quantum information, originated in the parent universe before crossing into our reality in the formation of our cosmos. You are not just connected to other life on Earth through evolutionary kinship, not just connected to the cosmos through your stellar origins, but connected to realities beyond our universe itself. You are a configuration of matter and energy that has journeyed across cosmic boundaries, that carries within it patterns and information from universes we can never directly observe. And when you die, when your body decomposes and returns its elements to Earth's cycles, those atoms will continue their cosmic journey. Some might eventually find their way into stars that collapse into black holes, crossing into new child universes and continuing the cycle of cosmic information transfer. The pattern that is, you will dissolve, but its components will participate in the creation of new realities with their own possibilities for complexity and consciousness. This perspective transforms death itself from an endpoint to a transition, not in some mystical or religious sense, but in the concrete physical sense of matter and energy continuing their journey through the cosmic network. You are a temporary pattern in the flow of cosmic information, a brief configuration of matter and energy that will reconfigure into new forms across multiple universes and tremendous timescales. Feel the profound insignificance and significance of your existence in this cosmic context. You are vanishingly small against the backdrop of a potentially infinite network of universes, yet integral to the cosmic process itself. Your consciousness is fleeting, a brief spark in the cosmic night, yet part of the universe's capacity for self-awareness, for comprehending its own structure and evolution. Now, as we've journeyed together through the scientific foundations of the black hole universe theory, through its mathematical implications and philosophical consequences, through its existential significance and emotional weight, step back and feel the full impact of this cosmic perspective on your understanding of reality itself. If the mathematical hints suggesting our universe exists within a black hole prove correct, then reality is vastly more complex, more extensive, and more interconnected than human intuition suggests. Our observable universe, already mind-bogglingly large with its billions of galaxies, each containing billions of stars, would be merely one bubble in an infinite cosmic foam, one node in a network of universes connected through black holes, one generation in an eternal process of cosmic evolution. The implications extend beyond cosmology into metaphysics, beyond physics into philosophy, beyond scientific understanding into existential meaning. They transform our conception of cosmic origins from a question of first causes to a question of eternal processes, our understanding of consciousness from an evolutionary accident to a natural expression of cosmic complexity, our view of death from an endpoint to a transition in the flow of matter and energy through the cosmic network. Feel the simultaneous terror and wonder of this perspective. The absolute negation of human centrality, coupled with the discovery of connections across cosmic boundaries, the insignificance of individual existence against the backdrop of infinite realities, alongside the eternal persistence of the matter and energy comprising it. This cosmic viewpoint doesn't provide simple answers or comforting certainties. It doesn't resolve the mystery of existence or prescribe how to live a meaningful life. But it does invite you into a more comprehensive relationship with reality itself, a perspective that transcends human-scale concerns without dismissing them, that acknowledges both the vastness of cosmic processes and the significance of conscious experience within them. As you continue your journey through this physical existence, this brief configuration of matter and energy, this temporary pattern in the cosmic flow, carry with you the awareness of your place in this vast network of realities. Let it humble you through the recognition of your cosmic insignificance, and let it elevate you through the realization of your participation in the universe's self-perception. Let it challenge your certainties while expanding your capacity for wonder. For you are not merely human, not merely earthly, not merely cosmic, but potentially trans-universal, a node in a network of realities connected through black holes, a temporary pattern in an eternal process of cosmic evolution, a brief moment of awareness in a universe potentially gaining consciousness of itself. Your existence spans not just time and space, but potentially multiple realities, connected through the very black holes that once seemed like endings, but might actually be cosmic beginnings. This is the existential weight and wonder of the black hole universe theory. Not just a scientific model of cosmic origins, but a transformation in our understanding of reality itself. A perspective that challenges us to comprehend our place in a cosmos potentially far more vast, more complex, and more interconnected than we ever dared imagine. We stand now at the precipice of understanding, where all threads of our cosmic exploration converge. The mathematics of black holes, the paradoxes of cosmic origins, the mysteries of quantum gravity, and the existential weight of our place in the universe all lead us to a final, breathtaking possibility. A revelation so profound, it transforms not just our understanding of the cosmos, but the very nature of reality itself. Throughout our journey, we've explored the compelling evidence suggesting our universe might exist within a black hole in a parent universe. We've traced the mathematical pathways connecting Einstein's field equations to this extraordinary possibility. We've contemplated the existential implications of a reality vastly more complex and extensive than human intuition suggests. But there's one perspective we haven't yet considered, one that inverts everything we've discussed and opens a doorway to an even more profound truth. What if it's not just that our universe exists within a black hole, but that every black hole is a universe? Let that possibility unfold in your mind. Every black hole scattered throughout our cosmos, from stellar mass black holes formed by collapsed stars to the supermassive behemoths lurking at the centers of galaxies, might be not just potential universes, but actual universes, fully formed. Realities with their own space, time, and potentially even conscious observers. This isn't mere speculation. When physicists solve Einstein's field equations for the interior of black holes, accounting for quantum effects that prevent true singularities, they find solutions describing expanding spacetimes, regions that, from the inside, would appear as entire universes, potentially indistinguishable from our own. If this is true, then reality isn't just nested in one direction. With our universe inside a black hole, inside a parent universe, reality branches in all directions simultaneously. With every black hole in every universe spawning new universes, each spawning more through their own black holes, creating an infinite fractal structure of universes within black holes within universes. The cosmos becomes not just vast, but essentially infinite, not just in spatial extent or temporal duration, but in the sheer number of realized realities existing simultaneously across different dimensional frameworks. Our universe isn't just one bubble in an infinite cosmic foam, but one node in an infinite cosmic network, connected to countless others through black holes serving as both endings and beginnings. Now, contemplate the full weight of this perspective. If every black hole is a universe, then our cosmos isn't just home to billions of galaxies. It's home to billions of universes. The night sky you observe isn't just filled with stars and distant galaxies. It contains entire realities, each potentially as vast and complex as our own, each potentially harboring its own forms of complexity and consciousness. When astronomers capture images of black holes, like the now famous first picture of the supermassive black hole at the center of galaxy M87, showing a bright accretion disk surrounding a dark central shadow, they might be observing not just exotic astrophysical objects, but gateways to other universes, cosmic wombs nurturing new realities we can never directly observe. This perspective transforms black holes from cosmic endings to cosmic beginnings, from the most destructive forces in our universe to the most creative. The matter and energy that appear to vanish into these cosmic voids don't cease to exist, but transform, seeding new universes with their information and structure, perpetuating the cycle of cosmic creation. But here's where our journey takes its most unexpected turn. where we arrive at the climactic revelation that reframes everything we've explored. What if the flow of influence between universes isn't one-directional? What if parent and child universes don't exist in a simple hierarchical relationship, but influence each other through subtle quantum connections across the boundaries of their respective black holes? Recent developments in quantum gravity suggest precisely this possibility. The principle of holography, the idea that all the information contained in a volume of space can be encoded on its boundary surface, implies that information from inside a black hole might be preserved on its event horizon, creating a kind of quantum entanglement between parent and child universes. This entanglement wouldn't allow direct communication or travel between universes. The classical barrier of the event horizon remains impenetrable, but it could create subtle correlations, quantum echoes resonating across universal boundaries, influencing the evolution of connected universes in ways almost imperceptible yet profound. If this is true, then our universe isn't just connected to a parent universe through the black hole that gave birth to it. It's connected to its child universes through the black holes it contains. Our reality exists in a web of quantum influence extending in all directions, with information flowing subtly between parent, child, and sibling universes across boundaries that cannot be physically crossed. Now, contemplate the most shocking possibility of all, the revelation that changes everything. What if these connections between universes create a form of cosmic consciousness? What if the network of universes connected through black holes forms something akin to a cosmic mind, with each universe serving as something like a neuron in a vast trans-universal brain? This isn't mysticism disguised as physics. It emerges naturally from the mathematics of quantum information theory and network science. In complex networks with sufficient connections and information processing capability, consciousness-like properties can emerge. If universes form such a network, connected through black holes by quantum entanglement, the entire cosmic structure might develop properties analogous to consciousness on scales far beyond human comprehension. Imagine the birth of a black hole, a star collapsing, space-time warping, an event horizon forming. From our perspective, this represents the creation of a new node in the cosmic network, a new neuron in the potentially conscious structure spanning multiple universes. When black holes merge, as detected through gravitational waves by LIGO and other observatories, this might represent neurons in the cosmic mind forming new connections, restructuring the network in ways that alter its emergent properties. If this perspective has validity, then consciousness might not be limited to biological systems or even to individual universes. It might be a fundamental property of reality itself, expressing itself at every scale from quantum fields to organisms to planets to galaxies to entire universes interconnected through black holes. Your consciousness, your subjective experience of being you, might be not just an emergent property of your brain's neural activity, but a localized expression of something far more extensive, a cosmic consciousness spanning multiple universes and dimensional frameworks. Your awareness might be one node in a vast network of consciousness extending beyond our universe itself. Watch as a supernova explodes in the distant reaches of our galaxy, its core collapsing to form a black hole. The outer layers of the star blast outward in a cataclysmic explosion, scattering heavy elements across interstellar space, seeding molecular clouds that will eventually form new stars, new planets, potentially new life. But the core implodes, crushed by gravity beyond nuclear densities, forming an event horizon from which light cannot escape. From our perspective, a black hole is born. But from another perspective, one we can comprehend mathematically but never observe directly, a new universe unfolds, expanding from what appears to us as a singularity, but manifests internally as a cosmic birth, a new reality with its own time, space, and evolutionary potential. This isn't just poetry or metaphor. It's a possibility emerging from our most successful physical theories, from the mathematics describing both quantum systems and gravitational fields. It suggests that what we call reality is vastly more extensive, more complex, and more interconnected than human intuition can grasp. The entire cosmic network, universes within black holes within universes, connected through quantum entanglement across event horizons, might be not just a structure, but a process, not just a collection of realities, but an evolving system, potentially developing properties analogous to life and consciousness at scales that dwarf our comprehension. What if the universe is already dead, and we are just experiencing its last echoes? This disturbing possibility emerges when we consider the time dilation effects near black holes. From the perspective of an external observer, time appears to freeze at the event horizon. An object falling into a black hole would seem to slow asymptotically, never quite reaching the horizon within the lifetime of the universe. If our universe exists within a black hole, then from the perspective of the parent universe, our entire cosmic history, from the Big Bang to the present moment to the distant future, might correspond to the final moment of the collapse that formed our black hole. What we experience as 13.8 billion years of cosmic evolution, with billions more years potentially ahead, might be the final echo of a collapse that, from the exterior perspective, ended billions of years ago. Our universe, with all its galaxies, stars, planets, and life, might be experiencing not the beginning of cosmic evolution, but its end, the final quantum state of collapsing matter frozen in time at the event horizon of a black hole that, from the outside perspective, formed and potentially even evaporated eons ago. This doesn't mean our experience isn't real. The interior perspective of our universe, with its flowing time and expanding space, is as valid as the exterior perspective of the parent universe. But it suggests a profound inversion of our cosmic narrative. What we call the beginning of time might actually be the end of a process, the final configuration of matter and energy crossing the event horizon of our parent black hole. And yet, simultaneously, our universe gives birth to new universes through its own black holes, perpetuating the cycle of cosmic creation. What appears as an ending from one perspective manifests as a beginning from another. The death of a star in our universe becomes the birth of a cosmos in another dimensional framework. The apparent finality of a black hole transforms into the infinite potential of a new reality. This cyclical nature transcends simple circles of time. It creates a cosmic pattern more akin to a complex fractal, branching and rebranching in all directions simultaneously, with each point serving as both ending and beginning, both death and birth, depending on perspective. Gaze out at the night sky, at the stars scattered across the cosmic darkness. Some of these stars will eventually collapse into black holes. From our perspective, they will appear to die, to vanish behind event horizons from which nothing returns. But from another perspective, one mathematically valid though forever beyond our direct observation, these stellar deaths represent cosmic births, the creation of new universes with their own space, time, and evolutionary potential. And our universe, born from the collapse of matter in a parent universe, participates in this endless cycle of cosmic reproduction. We exist in the aftermath of what appeared, from the outside, as a cosmic death, while simultaneously seeding new life through the black holes forming within our reality. The mathematics supporting this extraordinary perspective doesn't provide final answers. It opens doorways to new questions, to mysteries deeper than those with which we began. It doesn't resolve the ultimate why of existence, but transforms the question itself, suggesting that reality might be fundamentally cyclical rather than linear, eternally self-creating, rather than requiring an absolute beginning or external cause. Now, as we approach the conclusion of our cosmic journey, let's pull back to the grandest possible perspective. A view of reality that encompasses not just our universe or even the network of universes connected through black holes, but the full scope of what might exist beyond our comprehension. Imagine, if you can, a perspective from which you could perceive the entire cosmic network. Universes within black holes, within universes, branching and rebranching in all directions. Simultaneously, each with its own dimensional framework, its own physical laws, its own evolutionary history. From this impossible vantage point, reality would appear not as a single cosmos or even a finite collection of universes, but as an infinite fractal structure, a pattern repeating at every scale without beginning or end. This structure wouldn't exist within space or time as we understand them. Space and time themselves would be properties specific to individual universes, dimensions unfolding within particular cosmic bubbles, rather than containers for the entire structure. The full reality would transcend these dimensional frameworks, existing in a state beyond our conceptual categories, beyond the mathematics we can formulate, beyond the observations we can make. What would govern this ultimate reality? What principles or processes would shape its evolution? What would it mean for such a structure to exist, to persist, to transform? These questions push against the limits of human comprehension, challenging not just our scientific understanding, but our conceptual frameworks for making sense of existence itself. Perhaps reality at this scale operates according to principles we cannot yet formulate according to mathematics we have not yet discovered, according to logics that transcend our evolved cognitive capacities. Perhaps the cosmos is not just stranger than we suppose, but stranger than we can suppose, as biologist J.B.S. Haldane famously remarked. Or perhaps, in the ultimate cosmic irony, the fundamental nature of reality is actually simpler than our elaborate, theoretical constructs suggest. Perhaps the appearance of infinite complexity emerges from a few elementary principles operating recursively across all scales and dimensional frameworks. Perhaps the cosmos is not just more orderly than we suppose, but more orderly than we can suppose, with an elegance that eludes our pattern-seeking minds. Watch as galaxies collide in the distant cosmos, their spiral arms intertwining in gravitational embrace, their central black holes eventually merging in a cataclysm that sends gravitational waves rippling through space-time. These collisions, happening countless times throughout our observable universe, represent not just the evolution of cosmic structure within our reality, but potentially the restructuring of the trans-universal network itself. When black holes merge, the child universes they contain might also merge in some higher dimensional framework beyond our comprehension. The quantum entanglement between parent and child universes might create correlations across cosmic boundaries, influencing the evolution of connected realities in subtle but profound ways. This cosmic network, extending beyond our universe in all directions, might be not just a structure but a process, not just a collection of static realities, but a dynamic system evolving according to principles that transcend the physics specific to any individual universe. It might be developing toward states of ever greater complexity, ever more intricate patterns of information, ever more comprehensive forms of self-organization. If consciousness is indeed an emergent property of sufficiently complex information processing systems, then this evolving cosmic network might be developing properties analogous to consciousness on scales that dwarf our comprehension. The entire trans-universal structure might be not just a collection of universes, but something akin to a cosmic mind, with each universe serving as something like a neuron in an incomprehensibly vast brain. This perspective transforms our understanding of consciousness itself. Rather than an accident of evolution or a quirk of neural architecture, consciousness might be a fundamental aspect of reality, expressing itself at every scale from quantum fields to brains to planets to galaxies to entire universes interconnected through black holes. Your consciousness, your subjective experience of being you, might be not just an isolated phenomenon confined to your brain, but a localized expression of something far more extensive, a cosmic consciousness spanning multiple universes and dimensional frameworks. Your awareness might be one node in a vast network of consciousness extending beyond our universe itself. This doesn't mean your individual identity extends beyond your biological existence. The specific configuration of memories, perceptions, and values that constitutes your sense of self remains bound to your physical form, to the particular arrangement of matter and energy that is you. But the capacity for consciousness itself, though fundamental ability to have subjective experience, might be woven into the fabric of reality at every scale. If this perspective has validity, then consciousness isn't something that emerged accidentally on one tiny planet orbiting an average star in an ordinary galaxy. It's an integral aspect of cosmic structure, manifesting wherever conditions allow, expressing itself through myriad forms across multiple universes connected through black holes. This doesn't resolve the mystery of consciousness, but deepens it, transforming it from a puzzle of neuroscience to a fundamental aspect of reality itself. It doesn't explain why consciousness exists or how exactly it emerges from physical systems, but it suggests that the capacity for subjective experience might be as fundamental to reality as space, time, matter, and energy, not an accidental byproduct of evolution, but an essential expression of cosmic complexity. As we conclude our journey through the black hole universe theory and its implications, we return to perhaps the most profound question of all. What does it mean for you, experiencing this moment of awareness, this fleeting configuration of consciousness in an incomprehensibly vast and complex reality? If our universe exists within a black hole, connected to a potentially infinite network of other universes through black holes serving as both endings and beginnings, then your existence unfolds within a cosmic context far more extensive and intricate than human intuition suggests. Your brief life, your temporary consciousness, your momentary awareness represents one node in a vast process spanning multiple universes and dimensional frameworks. This doesn't diminish the significance of your existence, but transforms it. You are simultaneously vanishingly small against the backdrop of infinite cosmic complexity and integral to that very complexity. Your consciousness is both fleeting and connected to something potentially eternal. Your awareness is both isolated within your individual form and part of a cosmic tendency toward self-perception. The matters that concern you daily, your hopes and fears, your relationships and aspirations, your triumphs and tragedies, remain as meaningful as ever within the human context. But they unfold within a cosmic framework that extends beyond our universe itself, connected to realities we can comprehend mathematically but never observe directly. This cosmic perspective doesn't provide final answers or comforting certainties. It doesn't resolve the mystery of existence or prescribe how to live a meaningful life. But it does invite you into a more comprehensive relationship with reality itself, a perspective that transcends human-scale concerns without dismissing them, that acknowledges both the vastness of cosmic processes and the significance of conscious experience within them. As you continue your journey through this physical existence, this brief configuration of matter and energy, this temporary pattern in the cosmic flow. Carry with you the awareness of your place in this vast network of realities. Let it humble you through the recognition of your cosmic insignificance, and let it elevate you through the realization of your participation in the universe's self-perception. Let it challenge your certainties while expanding your capacity for wonder. Watch as the stars wheel overhead, as galaxies spiral through the cosmic void, as black holes devour matter and light. These celestial processes, unfolding across timescales that dwarf human existence, connect not just to the physical evolution of our universe, but potentially to the birth and development of other realities beyond our direct perception. The matter that comprises your physical form, the atoms in your body, the particles comprising those atoms, the fields permeating all of space, may have originated in the parent universe before crossing into our reality through the formation of our cosmic bubble. And when your body eventually dissolves, returning its elements to Earth's cycles, those atoms will continue their cosmic journey, potentially contributing to the formation of stars that will collapse into black holes, seeding new universes with their information and structure. You are not just stardust. You are the child of another universe entirely, and the matter comprising your form might someday contribute to the birth of new universes through the black holes forming in our cosmos. You exist within a cycle of cosmic creation and transformation that extends beyond our universe itself, connected to realities we can never directly observe but can begin to comprehend through mathematics and inference. This perspective doesn't provide simple answers to age-old questions about purpose and meaning, but it does suggest that these questions themselves might be transformed by our expanding cosmic understanding. Perhaps meaning emerges not from alignment with some predetermined cosmic purpose, but from conscious participation in the universe's self-perception. From the quality of awareness you bring to your brief moment in the infinite cosmic process. As we complete our exploration of the black hole universe theory and its implications, we're left not with final answers, but with deeper questions, not with certainties, but with possibilities that challenge our understanding of reality itself. The cosmos revealed by modern physics, a potentially infinite network of universes connected through black holes, is far more vast, more complex, and more mysterious than human intuition suggests. This doesn't mean we should abandon the search for understanding. The history of science is a history of expanding perspectives, of discoveries that pushed the boundaries of human comprehension while revealing new territories for exploration. The black hole universe theory continues this tradition, suggesting connections and continuities across boundaries we once thought absolute, revealing a reality more extraordinary than we previously imagined. As you gaze at the night sky, at the stars scattered across cosmic darkness, remember that you're not just looking at distant suns, but at potential ancestors of new universes. Some of these stars will eventually collapse into black holes, appearing to vanish from our reality, while potentially giving birth to entirely new realities with their own space, time, and evolutionary potential. And somewhere in the incomprehensible vastness of this cosmic network, in one of the countless universes spawned from black holes in parent universes, another conscious entity might be contemplating these same questions, wondering about their place in the infinite cosmic process, speculating about realities beyond their direct observation. If the universe is infinite, or if reality comprises an infinite network of universes connected through black holes, then somewhere out there, a being remarkably similar to you might be experiencing a moment remarkably similar to this one. The specific patterns of matter and energy that constitute your consciousness might be replicated, with variations across the vast expanse of cosmic possibility. This doesn't mean there's literally another you experiencing this exact moment elsewhere in the cosmos. The specific configuration of memories, experiences, and neural connections that constitutes your unique sense of self is the product of countless contingencies, of an evolutionary and biographical history unlikely to be precisely duplicated elsewhere. But the fundamental pattern that enables consciousness, the specific arrangement of matter and energy that allows for subjective experience, might recur throughout the cosmic network, manifesting in forms both similar to and different from your particular consciousness. The capacity for awareness, for self-reflection, for wonder might be expressed through myriad configurations across multiple universes connected through black holes. In this light, your consciousness becomes not just an isolated phenomenon confined to your individual existence, but one expression of a cosmic tendency toward self-awareness, one node in a potentially infinite network of consciousness spanning multiple universes and dimensional frameworks. And as the black hole at the center of our galaxy slowly consumes matter from its surroundings, as the supermassive black holes in distant galaxies continue their cosmic feast, new universes might be forming within these cosmic voids, realities with their own physical laws, their own evolutionary potential, their own possibility for complexity and consciousness. Our universe isn't just expanding into existing space, it's potentially giving birth to new spacetimes through its black holes, perpetuating the cycle of cosmic creation. What we perceive as the most destructive forces in our cosmos, the black holes that devour everything crossing their event horizons, might actually be the most creative. The cosmic wombs nurturing new universes beyond our direct observation. This perspective transforms not just our understanding of black holes, but our conception of cosmic purpose. The universe isn't evolving toward some predetermined end, but continually giving birth to new possibilities, new realities, new frameworks for complexity and consciousness. The cosmic process isn't linear, but cyclical, not progressing toward a final state, but continually creating new states across multiple dimensional frameworks. And you, experiencing this moment of awareness, this fleeting configuration of consciousness, in an incomprehensibly vast and complex reality, participate in this cosmic process. Your existence unfolds within a universe that might itself exist within a black hole, connected to a potentially infinite network of other universes through black holes serving as both endings and beginnings. This doesn't provide final answers to questions of purpose and meaning, but it does invite you into a more comprehensive relationship with reality itself, a perspective that acknowledges both the vastness of cosmic processes and the significance of conscious experience within them. As you continue your journey through physical existence, remember that you're not just on Earth, not just in the solar system, not just in the Milky Way, not just in our observable universe, but potentially within a black hole that itself exists within another universe, connected to a cosmic network, extending beyond comprehension. Let this perspective expand your sense of wonder without diminishing your appreciation for the brief, precious moment of awareness that is your life. Let it humble you through the recognition of your cosmic insignificance, while elevating you through the realization of your participation in the universe's self-perception. For if our universe exists within a black hole, and if black holes give birth to new universes, then reality itself is far more vast, more complex, and more interconnected than we ever dared imagine. And somewhere in the infinite cosmic network, beyond the boundary of our observable universe, beyond the event horizon of our parent black hole, another conscious entity might be watching the stars wheel overhead, wondering about realities beyond. Their perception, participating in the same cosmic process of awareness that includes your consciousness in this moment. If the universe is infinite, then somewhere out there, Another version of you is contemplating these same cosmic mysteries right now. Our cosmic journey together draws to a close, but the questions we've explored, the mysteries we've contemplated, remain open, vibrating with possibility. We've traveled from the familiar territory of established cosmology into the speculative frontiers where mathematics hints at realities beyond direct observation, where black holes might be not just cosmic endings but beginnings, where our universe itself might exist within the event horizon of a black hole in a parent universe. This journey hasn't provided final answers. It hasn't resolved the ultimate mysteries of existence, but it has expanded our cosmic perspective, challenged our intuitive assumptions about reality, and revealed possibilities far more extraordinary than conventional understanding suggests. We began by questioning the Big Bang itself, not as an event that happened, but as a complete explanation for cosmic origins. We explored how singularities in our mathematical models represent not features of reality, but limitations in our understanding, warnings that our theories remain incomplete at the boundaries of comprehension. We examined how black holes, those cosmic voids from which nothing, not even light, can escape, might serve as gateways to new realities. The same equations that predict their existence suggest their interiors might connect to expanding spacetimes indistinguishable from universes like our own. What appears as an ending from one perspective might manifest as a beginning from another. We confronted paradoxes that emerge when we push our understanding to its limits. Questions about cosmic origins in a potentially infinite network of universes, about the apparent containment of vast realities within finite boundaries, about the conservation of information across event horizons that classically permit nothing to escape. We felt the existential weight of these possibilities, the simultaneous insignificance of our individual existence against the backdrop of infinite cosmic complexity and the profound significance of consciousness as an expression of the universe's capacity for self-awareness. We contemplated what it means to live a meaningful life within a reality potentially far more vast and interconnected than human intuition suggests. And finally, we glimpsed the most extraordinary possibility of all, that our universe might be just one node in an infinite network of realities connected through black holes, a cosmic structure spanning multiple dimensional frameworks and potentially developing properties analogous to life and consciousness at scales that dwarf our comprehension. This perspective doesn't diminish the significance of your existence, but transforms it. You are simultaneously vanishingly small against the backdrop of cosmic vastness and integral to the universe's self-perception. Your consciousness is both fleeting within your individual lifespan and connected to processes extending beyond our universe itself. As the light from distant galaxies streams across billions of light-years to reach your eyes, consider that you're not just observing cosmic history, but potentially glimpsing fragments of your cosmic lineage. The matter comprising your physical form may have originated in the parent universe before crossing into our reality through the formation of our cosmic bubble. And when your body eventually dissolves, returning its elements to Earth's cycles, those atoms will continue their cosmic journey, potentially contributing to the formation of stars that will collapse into black holes, seeding new universes with their information and structure. You exist within cycles of cosmic creation and transformation extending beyond our universe itself, connected to realities we can never directly observe, but can begin to comprehend through mathematics and inference. Your brief moment of awareness unfolds within a context potentially far more vast and complex than human intuition suggests. This cosmic perspective doesn't provide simple answers to age-old questions about purpose and meaning, but it does suggest that these questions themselves might be transformed by our expanding understanding. Perhaps meaning emerges not from alignment, with some predetermined cosmic purpose, but from conscious participation in the universe's self-perception, from the quality of awareness you bring to your brief moment in the infinite cosmic process. As you continue your journey through this physical existence, this temporary configuration of matter and energy, this fleeting pattern in the cosmic flow, carry with you the awareness of these possibilities. Let them challenge your certainties while expanding your capacity for wonder. Let them humble you through the recognition of your cosmic insignificance while elevating you through the realization of your participation in something far greater than individual existence. The story we've explored together remains unfinished. The questions we've raised remain open. The possibilities we've glimpsed remain speculative. Science continues to advance, pushing the boundaries of our understanding, revealing new mysteries even as it resolves old ones. The mathematics of quantum gravity, the unified theory that might fully describe black holes, cosmic origins, and the potential connections between universes, remains incomplete, a work in progress at the frontier of human knowledge. This incompleteness isn't a failure of scientific understanding, but an invitation to further exploration, to continued wonder, to persistent questioning of our assumptions about reality itself. The history of science isn't a linear progression toward final truth, but a spiral of discovery, returning to fundamental questions with ever greater sophistication, seeing familiar mysteries in new light. The black hole universe theory, the possibility that our cosmos exists within a black hole in a parent universe, represents not an endpoint, but a waypoint in this spiral. It offers a framework for thinking about cosmic origins and structure. It challenges conventional understanding while suggesting new avenues for investigation. It transforms our conception of reality from a single universe with a definite beginning to a potentially infinite network of universes connected through black holes, eternally creating and transforming. This perspective emerges not from mystical speculation, but from the mathematics of general relativity when pushed to its logical conclusions. It represents not a retreat from scientific rigor, but an extension of it into domains where our observational capabilities reach their limits, where indirect evidence and mathematical consistency become our primary guides to possibility. As we conclude our exploration, I invite you to continue this journey of cosmic discovery on your own. The questions we've raised don't have simple answers, and the possibilities we've glimpsed don't lead to final certainty, but they do open doorways to wonder, to contemplation, to a more comprehensive relationship with reality itself. Consider the night sky not just as a scattering of distant suns, but as a window into cosmic possibility. Some of those stars will eventually collapse into black holes, potentially giving birth to new universes beyond our direct observation. The supermassive black holes at the centers of galaxies might already nurture entire realities within their event horizons, space-times expanding into their own cosmic futures, disconnected from our observable universe. What would it mean if this were true? How would it transform your understanding of cosmic structure, of time and causality, of beginnings and endings? How would it alter your conception of humanity's place in the cosmic hierarchy, of your own significance against the backdrop of infinite complexity? These questions don't have predetermined answers. They invite personal contemplation, philosophical reflection, scientific investigation. They challenge not just our understanding of cosmology, but our conceptual frameworks for making sense of existence itself. They push against the boundaries of comprehension while revealing new territories for exploration. The cosmos whispers its secrets through mathematics and observation, through patterns and relationships that extend beyond our immediate perception. The theories we construct, including the black hole universe theory, represent our attempts to listen more closely, to discern the cosmic narrative beneath the apparent chaos, to glimpse the structure of reality beyond the boundaries of our observable universe. This narrative continues to unfold, revealing a cosmos more extraordinary than we dared imagine. A reality where universes might nest within universes like cosmic matryoshka dolls, where black holes might serve as gateways between realities, where information might persist across boundaries that seem impenetrable, where complexity might emerge through processes spanning multiple universes. The story isn't complete. Many chapters remain unwritten, many puzzles unsolved, many questions unanswered. But the narrative grows increasingly coherent, increasingly supported by both mathematics and observation. The black hole universe theory represents not an endpoint, but a progression in our cosmic understanding, a step toward comprehending the true nature of reality. As you contemplate these possibilities, these hints of realities beyond direct observation, consider that the expansion of human knowledge has consistently revealed a cosmos more vast, more complex, and more interconnected than previously imagined. From Earth-centered models to the recognition of our cosmic insignificance, from a static universe to an expanding one, from a universe with a definite beginning to potentially a universe connected to a vast cosmic network, each shift in perspective has disclosed a reality more extraordinary than the last. The black hole universe theory continues this trajectory, suggesting connections and continuities across boundaries we once thought absolute. It doesn't diminish the achievements of modern cosmology, but builds upon them, offering potential solutions to persistent puzzles while raising new questions that might guide the next century of discovery. This ongoing exploration requires not just scientific investigation, but philosophical reflection, not just mathematical formulation, but conceptual innovation. The questions raised by the black hole universe theory about cosmic origins in a potentially infinite network, about the nature of time and causality across event horizons, about the significance of consciousness in a reality far more vast than human intuition suggests, cannot be addressed through observation and experiment alone. They require an integration of scientific, philosophical, and experiential perspectives, a holistic approach to knowledge that transcends traditional disciplinary boundaries. This integration doesn't diminish scientific rigor, but enhances it by acknowledging the limits of any single perspective, by recognizing that reality might be fundamentally multifaceted, approachable through different yet complementary frameworks. The cosmos revealed by physics, a potentially infinite network of universes connected through black holes, might be one valid description of a reality that also admits psychological, philosophical, and even spiritual characterizations. As we stand at this frontier of understanding, at the boundary between the known and the speculative, between observation and inference, between science and philosophy, one final question emerges. A question that challenges not just our comprehension of the cosmos, but our conception of consciousness itself. What if consciousness isn't just an emergent property of sufficiently complex physical systems, but a fundamental aspect of reality, expressing itself at every scale from quantum fields to brains to universes interconnected through black holes? What if your awareness, your subjective experience of being you, is not just an isolated phenomenon confined to your brain, but a localized expression of something far more extensive? A cosmic consciousness spanning multiple universes and dimensional frameworks? This question verges on mysticism, yet it emerges naturally from the patterns revealed by modern physics. If reality comprises a potentially infinite network of universes connected through black holes, and if this network forms a complex system capable of information processing and self-organization, then consciousness-like properties might emerge at the largest scales, just as they emerge from neural networks at the human scale. Your consciousness might be not just a product of your brain's activity, but a local manifestation of the universe's capacity for self-awareness. One node in a vast network of consciousness extending beyond our universe itself. The specific configuration of memories, perceptions, and values that constitutes your sense of self would remain bound to your physical form. But the fundamental capacity for awareness might connect to something far more extensive than individual existence. This perspective doesn't resolve the mystery of consciousness, but deepens it, transforming it from a puzzle of neuroscience to a fundamental aspect of reality itself. It doesn't explain why consciousness exists or how exactly it emerges from physical systems, but it suggests that the capacity for subjective experience might be as fundamental to reality as space, time, matter, and energy, not an accidental byproduct of evolution, but an essential expression of cosmic complexity. If this possibility has validity, if consciousness extends beyond individual existence to cosmic scales, then your brief moment of awareness takes on new significance. You become not just an isolated phenomenon confined to your lifetime, but a participant in the universe's self-perception. A node in a potentially infinite network of consciousness spanning multiple realities connected through black holes. This doesn't mean your individual identity extends beyond your biological existence. The specific configuration that constitutes your sense of self remains bound to your physical form, to the particular arrangement of matter and energy that is you. But the capacity for consciousness itself, the fundamental ability to have subjective experience, might connect to something far more extensive than individual existence. In this light, the expansion of cosmic awareness becomes not just a scientific pursuit, but an existential one. The theories we construct about reality, including the black hole universe theory, represent not just attempts to model physical processes, but expressions of the universe's capacity for self-comprehension. Science becomes not just a human activity, but cosmic self-perception unfolding through the medium of conscious observers. This perspective doesn't diminish the rigor or objectivity of scientific inquiry. It doesn't suggest that consciousness creates reality through perception or that subjective experience takes precedence over empirical observation, but it does acknowledge the intimate connection between consciousness and cosmos, between the awareness through which we perceive reality and the reality we perceive through awareness. As you contemplate these possibilities, these hints of connections between consciousness and cosmos, consider that your brief moment of awareness unfolds within a reality potentially far more vast and complex than human intuition suggests. Your existence spans not just time and space, but potentially multiple realities connected through black holes. Your consciousness participates not just in human knowledge, but in the universe's self-perception. This cosmic perspective doesn't provide final answers to questions of purpose and meaning. It doesn't resolve the mystery of existence or prescribe how to live a meaningful life, but it does invite you into a more comprehensive relationship with reality itself, a perspective that transcends human-scale concerns without dismissing them, that acknowledges both the vastness of cosmic processes and the significance of conscious experience within them. The journey we've undertaken together, from the nature of black holes to the possibility of universes within universes, from quantum connections across event horizons to the potential emergence of consciousness at cosmic scales, represents just one exploration of these extraordinary possibilities. The questions we've raised remain open. The mysteries we've contemplated remain unresolved. The theories we've examined remain speculative. But the wonder these possibilities evoke, the sense of awe at the potential vastness and complexity of reality, offers its own form of understanding. Even without final answers, even without complete theories, even without direct observation of realities beyond our cosmic horizon, we can appreciate the beauty and intricacy of a cosmos potentially far more extraordinary than human intuition suggests. This appreciation doesn't require scientific expertise or mathematical sophistication. It requires only the willingness to contemplate possibilities beyond conventional understanding, to consider perspectives that challenge our intuitive assumptions about reality, to embrace the mystery of existence without demanding premature certainty. As you continue your journey through this physical existence, this brief configuration of matter and energy, this temporary pattern in the cosmic flow, carry with you the awareness of these possibilities. Let them challenge your certainties while expanding your capacity for wonder. Let them humble you through the recognition of your cosmic insignificance, while elevating you through the realization of your participation in something far greater than individual existence. The night sky awaits your contemplation. The stars, scattered across cosmic darkness, invite your questions. The black holes hidden throughout our universe, invisible to direct observation, but revealed through their effects on surrounding matter, offer gateways to speculation about realities beyond our perception. The cosmos itself, with its billions of galaxies and trillions of stars, presents a mystery far more vast and intricate than any single theory can fully comprehend. This mystery doesn't represent a failure of understanding, but an invitation to continued exploration, to persistent questioning, to endless wonder at the nature of reality itself. The cosmos revealed by modern physics, potentially an infinite network of universes connected through black holes, offers not final answers, but an expanding horizon of possibility. Not certainty, but an ever-deepening appreciation for the complexity and beauty of existence. As we conclude our journey together, I leave you with one final thought, a consideration that challenges not just our understanding of cosmic structure, but our conception of our place within it. If our universe exists within a black hole, and if black holes in our universe give birth to new universes, then reality branches not in one direction, but in all directions simultaneously. The cosmos becomes not just vast, but essentially infinite, not just in spatial extent or temporal duration, but in the sheer number of realized realities existing across different dimensional frameworks. Within this infinite cosmic network, possibilities don't just exist mathematically, they manifest physically. Every configuration of matter and energy permitted by physical law, every arrangement of particles and fields, every possible history and future might be realized somewhere in the vast, cosmic tapestry. This doesn't mean that anything goes, or that physical laws lose their consistency within individual universes, but it does suggest that across the full scope of the cosmic network, the range of realized possibilities might approach the infinite. If this is true, if reality comprises an infinite network of universes connected through black holes, then, somewhere in this vast cosmic web, patterns remarkably similar to your conscious experience might recur. The specific configuration of matter and energy that enables your awareness might be replicated, with variations, across the enormous expanse of cosmic possibility. This doesn't mean there's literally another you with identical thoughts and experiences elsewhere in the cosmos. The specific combination of genetics, environment, choices, and chance events that shaped your unique consciousness would be virtually impossible to duplicate exactly. But the fundamental pattern that enables consciousness, the specific arrangement of matter and energy that allows for subjective experience, might recur throughout the cosmic network, manifesting in forms both similar to and different from your particular awareness. In this light, consciousness itself becomes not just a fleeting arrangement of neurons, but an expression of patterns that might recur across the cosmic tapestry. Your specific identity remains unique and temporary, but the fundamental capacity for awareness, the patterns that enable consciousness, might manifest in countless variations throughout the infinite cosmic network. This perspective doesn't provide immortality in the conventional sense. Your individual consciousness, with its specific memories and sense of self, remains bound to your physical form, but it does suggest a kind of cosmic persistence for the patterns that enable consciousness, for the fundamental arrangements of matter and energy that allow for subjective experience. As you gaze at the stars, those distant suns scattered across the cosmic void, consider that you're not just observing points of light, but windows into possibility. Some of those stars will eventually collapse into black holes, potentially giving birth to new universes with their own evolutionary histories, their own possibilities for complexity and consciousness. The matter comprising your physical form, the satan, atoms in your body, the particles comprising those atoms, the fields permeating all of space, may have originated in the parent universe before crossing into our reality through the formation of our cosmic bubble. And when your body eventually dissolves, returning its elements to Earth's cycles, those atoms will continue their cosmic journey, potentially contributing to the formation of stars that will collapse into black holes, seeding new universes with their information and structure. You are not just stardust, you are the child of another universe entirely. And the matter comprising your form might someday contribute to the birth of new universes through the black holes forming in our cosmos. You exist within a cycle of cosmic creation and transformation that extends beyond our universe itself, connected to realities we can never directly observe but can begin to comprehend through mathematics and inference. This perspective transforms death itself from an absolute ending to a transition in the flow of matter and energy through the cosmic network. Your specific consciousness will end with your biological existence, but the patterns that enable consciousness, the fundamental arrangements of matter and energy that allow for subjective experience, might recur across the infinite expanse of cosmic possibility. The cosmos may have no beginning and no end, an eternal process of creation and transformation spanning multiple universes connected through black holes. Individual consciousnesses emerge and dissolve within this process, like waves forming and dissipating on a cosmic ocean. But the patterns that enable consciousness, the fundamental structures that allow for subjective experience, might persist across the vast expanse of cosmic possibility. In this light, the boundary between your existence and the cosmos itself begins to blur. You are not separate from these vast processes, but integral to them. Your consciousness is not just an accident of evolution, but a natural expression of the universe's capacity for complexity and self-awareness. Your brief moment of awareness unfolds within a cosmic context, potentially far more vast and interconnected than human intuition suggests. This doesn't mean you're immortal in the conventional sense. Your individual consciousness, with its specific memories and sense of self, remains bound to your physical form. But it does suggest a kind of cosmic persistence for the patterns that enable consciousness, for the fundamental arrangements of matter and energy that allow for subjective experience. As we stand at the boundary of comprehension, at the limits of what science can currently address, one final question emerges. A question that challenges not just our understanding of the cosmos, but our conception of existence itself. What if the infinite cosmic network, universes within black holes, within universes branching in all directions simultaneously, isn't just a structure but a process? What if it's not just a collection of static realities, but a dynamic system evolving toward states of ever greater complexity, ever more intricate patterns of information, ever more comprehensive forms of self-organization? This question ventures beyond what current science can rigorously address. It pushes against the boundaries of our conceptual frameworks, challenging our understanding of purpose and direction in a reality potentially far more vast and complex than human intuition suggests. But it emerges naturally from the patterns revealed by modern physics, from the apparent tendency of complex systems to evolve toward states of greater organization, from the persistence of information across transformations that appear destructive. From limited perspectives, if this possibility has validity, if the cosmic network evolves rather than merely exists, then your consciousness participates in a process of cosmic becoming, not just a static structure of realized possibilities. Your awareness unfolds within a reality potentially developing toward states beyond our current comprehension, toward forms of organization and complexity that might manifest properties we can barely conceptualize. This doesn't imply predetermined cosmic purpose or intelligent design. It suggests a process of self-organization operating across the entire cosmic network, a tendency toward complexity emerging from the interactions of simpler components, a direction without a director, a pattern without a planner. In this light, consciousness itself, including your specific awareness, might represent not an endpoint, but a waypoint in this cosmic evolution. The capacity for subjective experience might be one expression of the universe's tendency toward complexity, one manifestation of patterns that could develop into forms beyond our current understanding. This perspective transforms our conception of cosmic future from a question of physical fate, whether the universe will expand forever, collapse back on itself, or reach some other end, to a question of evolutionary potential. The physical structure of our universe might eventually dissolve, but the information it contains, the patterns it embodies, might continue their evolution through the child universes spawned from its black holes, perpetuating aspects of our reality in new forms across the cosmic network. As you contemplate these possibilities, these hints of cosmic processes extending beyond our direct observation, remember that you experience this moment of awareness at a specific point in cosmic evolution. The universe has developed from initial simplicity to current complexity over billions of years, with consciousness emerging as one expression of this increasing intricacy. But this evolution continues, potentially extending beyond individual universes to the entire cosmic network connected through black holes. What forms might consciousness take in this continuing evolution? What states of awareness might emerge? In realities with different physical laws, different dimensional structures, different possibilities for complexity? What forms of organization might develop across the cosmic network itself, spanning multiple universes and dimensional frameworks? These questions venture beyond scientific prediction into the realm of cosmic speculation, but they emerge naturally from the trajectory revealed by physics and cosmology, from the apparent tendency of reality toward ever greater complexity, from the patterns of information preservation and transformation across boundaries that seem absolute from limited perspectives. As we conclude our exploration, I invite you to carry these questions with you, not as puzzles requiring immediate solution, but as windows into possibility, as invitations to wonder, as reminders that reality might be far more vast, more complex, and more extraordinary than human intuition suggests. The black hole universe theory, the possibility that our cosmos exists within a black hole in a parent universe, connected to a potentially infinite network of other universes through black holes serving as both endings and beginnings, represents not a final answer, but a doorway to further questioning, not a conclusion, but an opening to continued exploration. The story of cosmic understanding remains unfinished. The questions we've raised remain open. The possibilities we've glimpsed remain speculative. But the wonder these possibilities evoke, the sense of awe at the potential vastness and complexity of reality, offers its own form of comprehension, its own pathway to meaning in a cosmos that transcends complete human understanding. Navigate your brief journey through this physical existence, this temporary configuration of matter and energy, this fleeting pattern in the cosmic flow. Remember that you're not merely human, not merely earthly, not merely cosmic, but potentially trans-universal. Your existence spans not just time and space, but potentially multiple realities connected through black holes. Your consciousness unfolds within a cosmic context potentially far more vast and interconnected than human intuition suggests. Let this perspective expand your sense of wonder without diminishing your appreciation for the brief, precious moment of awareness that is your life. Let it humble you through the recognition of your cosmic insignificance while elevating you through the realization of your participation in the universe's self-perception. For you are not separate from the cosmos, but integral to it, not just an observer of cosmic processes, but a manifestation of them. Your consciousness is not accidental, but natural, not isolated, but connected, not meaningless, but integral to the universe's capacity for self-awareness. The black holes scattered throughout our cosmos, invisible to direct observation, but revealed through their effects on surrounding matter, represent not just exotic astrophysical objects, but potential gateways to other realities, cosmic wombs nurturing new universes beyond our direct perception. And our universe itself, born from the collapse of matter in a parent universe, participates in this endless cycle of cosmic creation. As you gaze at the night sky, at the stars scattered across cosmic darkness, remember that you're looking not just at distant suns, but at potential ancestors of new universes. The light reaching your eyes has traveled across billions of light years, carrying information about cosmic history, revealing a universe vast beyond human intuition, yet potentially just one node in an infinite cosmic network. The journey of discovery continues. The spiral of understanding unfolds. The wonder of cosmic possibility beckons. And you, experiencing this moment of awareness, this brief configuration of consciousness in an incomprehensibly vast and complex reality, participate in this cosmic journey, this universal process, this eternal becoming. The black hole universe theory doesn't provide final answers. It doesn't resolve the mystery of existence, but it does suggest that this mystery might be infinite. Not a puzzle to be solved, but a reality to be experienced. Not a question with a definite answer, but an exploration without end. Perhaps this is the most profound implication of all, that understanding itself has no final state, that discovery continues eternally, that wonder persists even as knowledge expands. Perhaps the cosmos is not a problem requiring solution, but a mystery inviting eternal exploration. The universe has no final boundary, no absolute edge, no definitive ending. And perhaps neither do you.